Okay, so the next slide is about the issue. So for those of you who are new here, the issue is the Asian citrus psyllid, or ACP. It's a small insect that feeds on citrus plants. It feeds on all varieties and a few close relatives. It's a sap-sucking insect. It has piercing, sucking mouth parts. It feeds on the phloem of the citrus trees. And as it feeds, it can transmit a bacterium called CLAS, and that bacterium can cause the citrus disease Huanglongbing, or HLB. Citrus that's infected with HLB suffers from significant decline in production, both in terms of quantity as well as quality of the fruit. The plants die ultimately that are infected by HLB, and there is no cure. So this is a significant, a really serious insect disease pest problem for citrus worldwide. Here in the US, the Florida citrus industry has been significantly just devastated by HLB. The Florida industry has been able to hang on because it's largely a juicing industry. So they're able to blend and add to and mix their product to mask the impacts of HLB. Of course, here in California, we're a fresh fruit state. We do not have the luxury of mixing and blending and masking our product. So our focus really is on preventing, delaying, and minimizing the impacts of ACP and HLB here in the state. So in order to do that, next slide, please. We need to understand how ACP and HLB are spread. So in order to prevent it. So ACP is insects, the adults have wings and they fly around on their own, feeding from tree to tree. They're also very small, so they can become windborne and travel even further. ACP can also be moved artificially by human activity, accidentally carried on clothing or personal items, vehicles, and equipment as they move from site to site. Once an ACP insect feeds on an infected HLB-infected tree, it can pick up the bacterium. And once that bacterium is inside the insect body, it's there for the rest of that insect's life, and it will go wherever that insect goes. Similarly, any plant material from an infected tree will carry the HLB bacterium with it as well, and moved around, with any human activity there. So the primary focus of prevention is suppressing ACP populations out in the field. So the fewer ACP are out there, the less it can spread. And I'll be talking more about that in my slides. Also, best practices for keeping clothing, personal items, vehicles, and equipment free of ACP and any plant material, both when entering any orchard as well as leaving an orchard. Using only certified budwood and new plantings, and complying with quarantine regulations for containment of ACP and HLB. And Sandra and Keith, our later speakers, will talk more about that. Next slide, please. So in counties like Ventura, where ACP is already established, and ACP is established throughout Southern California from Santa Barbara County on down. Counties where ACP is established, like here in Ventura, the statewide citrus program follows the recommendations of research entomologists and plant pathologists and promotes area-wide management of ACP. Can we get to the next slide, please? Thank you. So area-wide management is where multiple growers in an expanded area treat at more or less the same time to maximize the impacts of their treatments. So the statewide recommendation is for area-wide management is then implemented at the local level, right? So the local industry members, citrus growers, get together and modify the area-wide program, create an area-wide program that fits the local conditions. And so we're fortunate enough here in Ventura to have a very strong ACP-HLB task force organized by the Farm Bureau. The task force meets annually to review and tweak the treatment schedule and the area-wide protocols for the upcoming year. And this is a collaborative effort, right? So the task force includes UC scientists, local PCAs, applicators, growers, packing house members. And together they consider the latest research, field observations, weather conditions, local logistics, anything that needs to be considered in developing and optimizing a treatment program for ACP. And then more recently, UC researchers, Dr. McRoberts' lab has developed a degree day modeling for ACP. So we have that in to add to the mix of information, which is pretty exciting. Okay, so next slide, please. So the county, the citrus growing areas in Ventura have been broken up into smaller areas called psyllid management areas, or PIMAs, because psyllid is spelled with a P. And there's 50 psyllid management areas. This map can be found on the citrusinsider.org website under their maps tab, psyllid management areas, Ventura. And you can just zoom into wherever your orchard is, determine what psyllid management area you're in, and then take that to the schedule to find your treatment window. Next slide, please. So the next slide is the current treatment schedule. This is for 2024-25. This document has been distributed. Sandra and I have sent it out in our monthly email updates. Hopefully everybody is on that email list and you have received this document. If you have not, the next slide will have a QR code so you can directly access this PDF document. It also will have another QR code that you can sign up for our monthly email updates if you're not getting them already. And if you miss any of this, if you don't get your cameras ready for the next slide, hint, hint, you can just contact me or Sandra, and we'll be happy to get you set up. But basically, the schedule this year is very similar to the schedule last year. We have 3 main treatment cycles: winter, summer, and fall. We're in the middle of the summer treatment now. In general, the treatment windows for each PIMA are about 3 weeks long, and they overlap by about a week, so that the whole county is covered in 3 months. The summer treatments are a little bit different. They're drawn out to allow a little bit more flexibility for growers during the growing season. So I think we're ready for the next slide with the QR code. So again, the one on the left will take you straight to that PDF of the schedule, the current schedule. And the one on the right is to sign up for those monthly email updates from the grower liaisons. Okay. And okay, next slide, please. So what materials to use for your treatments? The University of California, again, entomologists have come up with maintain a list at the UCIPM website. This is a list of ACP effective materials to choose from for your area-wide treatments. This is for management of ACP in the field. It's a wide range of materials, including conventional, broad spectrum, softer, more selective materials, as well as some organic options. Keep in mind with the organic options, because they have low to no residual activity, for every conventional treatment that's recommended, it requires 2 organic treatments about 10 days to 2 weeks apart. I just want to mention that, yeah, and again, there's a QR code to take you to that website, or you can just search UCIPM ACP. And that website has a lot of information about monitoring, protocols, materials to choose from, rates, and so forth. I just want to mention that, again, this longer list, more comprehensive list, is for management of ACP in the field. If you are looking for materials to use to comply with quarantine requirements for pre-harvest treatment, that's a different list. It's a much shorter list. It's only broad spectrum, and it can be found in a CDFA document in separate locations. I just want to, and Sandra and Keith will, give more details on that. But I just want to make clear, remind everybody they're 2 separate lists. Okay. Okay, so next slide, please. So the important elements of ACP management are, participating in the area-wide treatments, treating as close to your window as you can, and as early within your window as you can, especially in the fall, because that's when we've, in many years, we'll see what happens this year. Usually, we have warmer temperatures throughout the summer and into the fall, and that's the time when the psyllid populations are starting to build up. So we want to get on them as soon as we can in the fall. Really important is monitoring and scouting regularly in your orchards for signs of ACP, and treating if you see signs of ACP in your orchard. Now, in recent years, ACP numbers have been really low. They've been really hard to find. But that doesn't mean we have to stop looking. We need to stay vigilant because we really just have to keep a lid on the ACP populations, not give them any room, not take our eye off the ball here. Because even though ACP numbers may be low, HLB is out there and it's expanding, and we don't want to give ACP any chance to blow up and spread it even more. So we really highly suggest working with a professional pest management professional. PCAs are highly trained and skilled in scouting for insects like ACP and in optimizing treatment programs to fit the specific conditions of your orchard. They really can help with efficacy in treatments and cost efficiency of program management as well. So we really recommend working with a professional if you can. We have a list of PCAs working in the county. So if you need a referral, please, let us know. We'll be happy to get that to you. Next slide, please. And then I'll just mention really briefly a couple of other management options. We have a number of experts here with us today who will get into a lot more detail on this. But this is really just to remind us that ACP management, it's a whole wheelhouse of options and tools available, and we really should be using as many of them as we can. So barriers and windbreaks can help prevent intrusion of ACP from outside areas. Conservation of biological control that might be out there is really important. Planting border or cover crops to provide habitat. Controlling ants is really critical. ACP produce honeydew. Ants feed on the honeydew. They will fight to the death to protect that food source, and they interfere with biological control. So again, we'll be hearing more on those from the experts. And now I'll hand it over to Sandra for HLB. Thank you.
Hi, everyone. Just as a reminder, those that need DPR CEUs, there's a sign-up sheet out front. If you were not able to register, there's a blank sign-in sheet for you. Otherwise, just place your signature in there. Also, my slides have a lot of QR codes, so just be aware. Feel free to take pictures because those do link up to a lot of regulatory documents as well. There have been reports that ACP populations have been low over the past couple of years, but that doesn't mean that HLB fines have been low. Actually, those have increased, as well as the number of quarantines that have increased. So again, work with your PCA and farm management companies or grove managers so that they could help monitor and provide recommendations for your specific groves. Next slide. So reminder, again, HLB, there's no cure. HLB kills citrus trees. There's a loss in production, size, and quality, as well as additional grower costs and then management also. I do want to point out that in California, we've done a great job actually of keeping HLB at bay. Our numbers are fairly low considering the number of years we've had HLB. So the spread has been, I think, minimal. It is especially contained in Southern California and also in residential groves. There are no reported commercial groves where HLB has been found. Next. I attended the HLB conference, so there are some takeaways I'd like to share with everybody. I was hoping to hear about HLB cures. That was not the case. There were no presentations that were based on any cures. Rather, the focus was more on HLB management. HLB management included like injecting antimicrobials, which is oxytetracycline and streptomycin, which are not even available in California. And basically the goal was to keep the trees as healthy and productive for as long as possible. An example is new plantings, which may have cups or covers under protective screens. Up until the point that they are established, then those cups are taken off. But it was known that HLB would infest those younger trees as well. And then for more mature trees, screen houses may be used at that point. Also, the injection of the antimicrobials meant you were drilling into the tree to inject those antimicrobials as well. When managing HLB, you're not removing positive trees anymore. So obviously the spread of HLB will be greater or faster. And continuing to suppress ACP was still key. You still needed to keep the ACP numbers low to help minimize any impacts of HLB. Also, broad spectrum materials are used at that point as well, and you're treating more often. No, this is when you're managing HLB. So this is just what I'm hearing from the HLB conference. So thanks for clarifying that. We are in California still taking out positive trees, yes. So the next slides I'm going to show is a series of slides that essentially show the spread of HLB from, I think, as early as 2017. Next slide. June 2017, next slide. Now we've got all 4 counties impacted. Next. 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 This one now has San Diego included. It has its own quarantine. That's December of 2021. Next. Here we are, 2022, September. Next. Next. And then this is February of this year. So now we've got the Ventura quarantine in Santa Paula, and San Diego has 3 quarantines. I left this at February of 2024. Currently for June, the quarantines have stayed the same, so they haven't increased. Having said that, that doesn't mean that HLB fines have not increased. They have in all of the counties where there are quarantines. So the delimitation areas or the 250-meter areas have expanded, but the quarantines themselves have not. So there is an increase in the acreage of the delimitation areas. The QR code is linked to the Citrus Insider HLB, where there are HLB counts as well as this map. Next. As I said, HLB counts have increased. So the 2024 graph and chart is up through last Friday. So it is much shorter because we've got a little over 6 months left for HLB fines to occur, and I have no doubt that they will be found. Note, though, that 2022 to 2023, the growth of HLB fines more than doubled that year. So we're in a fairly large number. The Ventura current numbers are highlighted in yellow. Again, that was as of last Friday. So we are at a total of 73 HLB tree fines for Ventura. Next. This is Santa Paula's HLB quarantine. This QR code will take you directly to the CDFA website. It's an interactive quarantine website. You can plug in an address and see the proximity of that address to the HLB quarantine. It is, yeah. Next. When HLB is detected, this is essentially the response. This QR code will take you directly to the HLB response summary document. So first, there is a 250, well, it's not first, these can all happen at the same time. There is a 250-meter delimitation area that is established. All property owners with citrus are notified in that 250-meter area. CDFA does surveying and sampling of all the citrus in that area. If there happens to be a commercial grove, they will survey the perimeter of the commercial grove. And when I say commercial, I'm going to say commercial because Ventura is commercial or residential. There are other areas where they are just 25 plus trees, yet they're still residential because they're not really producing. They just happen to have more than 25 trees. There is a mandatory treatment and then removal of the positive tree. And all of the citrus that's in the 250-meter areas have a mandatory treatment as well, regardless if you're residential or commercial. A hold is placed pending the actual quarantine. And then the 5-mile quarantine is established. And when you're in this situation and there are commercial groves, whether you're in the 250-meter area or 1 mile out from the positive find, or even in the quarantine, both Kristen and I will be notifying growers if we have your contact information that, where you are in the quarantine, whether you're in the 250, 1 mile, or 5 miles out, just so that you're aware that you're close by. Next. I'm bringing this up. The next presenter, Keith Okasaki, he's with CDFA, will be going into this, I believe, in more detail, but this QR code takes you to the HLB quarantine requirements. It's also titled The Information for Citrus Growers and Grove Management. This document is 4 pages long. What I have here is just the first half of the page. I get a few comments and questions about this, which is why I'm bringing it up here just as an overview for Keith to go a little bit more into this. This document, you see some links to the quarantine zones, the bulk citrus and HLB, and other links in there. My point though is these 5 items that are listed on this front page. And I know it's a lot to take in when you're a grower, because I do walk growers through what they need to do, because I'm usually the one contacting them when they are in a delimitation also. So I get that it's confusing. So again, I want to point out this document because it does step through the requirements and what is needed. Always feel free to contact either, I think it's Keith or CDFA. There's a website on this document, or either Crescent and I, and we can forward you to the appropriate people as well. So I'm just going to go over some of the 5 items. So one is an ACP-HLB compliance agreement. So if you're moving fruit in, out, or within the quarantine, that compliance agreement, and it may be different than the ACP compliance agreement that you had signed initially. So that is needed, and that travels along with the load as well. There's an ACP-free declaration form, or an HLB pest risk mitigation form that is submit to the origination and the receiving counties. So that has to happen. There's also a time frame, so make sure you read through that, when you are impacted. Bins always have to be tarped or moved in an enclosed vehicle. And the load must be delivered to an approved packer or processor, because the packers and processors also have to sign an HLB compliance agreement. Again, the original forms go with the load, and then they're distributed to the packer or processor. Also, to reiterate what Cressida said, so page 4 of this document has the short list of pesticides for HLB. It is a short list. It's, I believe, all broad spectrum, which is a completely different list than the area-wide treatment list. And it is listed out again on page 4, which Keith again will go over this, and always use the links. So if you have a paper copy of this document, I still recommend using the links, because this document may change periodically. It may be updated, so there may be requirements that you no longer need to do, or that you may need to do because they're new. So just be aware of that. Next. I'm going to go over some HLB testing options. There are some options. You can contact the CDFA pest hotline and ask them to look at a tree, test a tree for you, so they will come out. Then there's the Citrus Pest Detection Program. That is the certified lab in Tulare. The QR code will take you to the document that has the instructions and a phone number, as well as their website. And then there's the bulk citrus testing. So that's a vendor who technology evolving solutions. That QR code will take you directly to that website. The president is Doug Hill. He's the contact. And we've been notified that he has a grant, so there may be low or no costs, to growers electing to do that. And just know that all organizations that have positive fines will have to report those to CDFA as well. So just know that. Next. I'm going to go over neglected and abandoned groves also, just as a reminder that it is a refuge for ACP. If anyone sees abandoned neglected groves, please report those to the County Ag Commissioner's office. They can contact the property owner and kind of move forward with that. What I've also seen, especially in the San Diego area, there just happened to be a huge grove that was split up or subdivided into many, many properties, and even like a community with the remnants of that grove in there. Most of those trees are non-production trees, so they basically sat there and they happened to fall into delimitation areas. And, the last thing anyone wants is for me to contact them and have to do an immediate action, treating trees. And again, most of them elected to take their trees down to a residential level, but they're always in shock, when I call them up and have to quickly deal and quickly act with what's happening. So those that are also considering tree removal, I would suggest maybe starting it sooner rather than later, if you may, because you may end up in a delimitation area where you would have to act quickly. Next. Thank you so much. We have questions?
I have one question online. What are the rules for non-bulk citrus shipments? Some companies and growers are doing online sales of non-bulk quantities less than 25 pounds.
So that is a regulatory question, and Keith should be able to answer that.
Great. Well, thank you so much. Or go ahead.
Maybe premature, but when you have to remove the tree, what are the parameters of removing a tree? You have to burn it, grind it.
So the question was, when you have to remove the tree, what do you need to do with the tree that you've removed afterwards?
You can chip and shred it, keep it on site, or bag it up, hold it for 2 weeks before disposal. You could also just let it stay there stay on site until the tree dies, and then double bag it and dispose of it.
So I'm going to turn it over to Keith from CDFA. Keith's presented at most of our meetings in the past, and he is coming to us from Sacramento, and I'll hand it over to him.
All right, good morning. I'm Keith Okazaki. I am the statewide regulatory manager for CDFA Citrus Division. My role with citrus is to create or interpret and enforce citrus quarantine regulations to prevent the artificial spread of ACP, HLB, sweet orange scab, other citrus pests and diseases throughout the state. As always, thank you for the opportunity to meet with you all. Sorry I couldn't be there in person. Spending a day in Ventura is always a lot nicer than 102 degrees we have in Sacramento today. So I appreciate how involved and engaged this group is, and we'll continue to do what we can from CDFA to communicate as much as possible throughout the year so we're all on the same page. So I'm going to start with before we get into ACP, brief fruit fly updates over the last almost 2.5 months. I've been the acting branch chief for CDFA's Pest Detection and Emergency Projects branch, which is responsible for fruit fly detection and eradication, as well as just about every other invasive pest in California that's not ACP and HLB. So I just wanted to highlight some of the work that we are doing because this does impact the citrus industry. I also believe that Nathan Rosenblum, who's our local regulatory environmental scientist, is at the meeting. And we also have Jennifer Willems online, who is the Central District Manager for citrus, which includes Ventura, who's in charge of survey detection and tree removal, among other things. So we have people here who can help answer citrus-related questions. So we currently have 5 active fruit fly quarantines, down from the 7 we had last time we spoke, which is always good news. All the quarantines at this point are moving well towards being lifted, as long as we continue to not have any additional detections. So I know that the Queensland Fruit Fly project is in Ventura and Thousand Oaks. So with Q-Fly, we've only detected 3 flies. For this project, we've deployed almost 1,100 delimitation traps, cut 300 pounds of fruit to conduct larval survey, treated 185 properties. We haven't had a detection in some time. And to lift a quarantine, we have to complete 3 consecutive life cycles without a detection, which is represented by that F3 date, which is currently projected for July 30th, but can be adjusted based on weather or any additional detections. Just for comparison to the Oriental fruit fly quarantine in San Bernardino and Riverside, since I know that's made a lot of news and headlines over the last several months, where we've caught over 700 flies. I think we've deployed almost 5,000 traps, cut over 24,000 pounds of fruit, and stripped and removed almost 1.5 million pounds of fruit in a large-scale fruit removal area, where we found breeding populations. For the projected end dates of the quarantines, we've recently completed 2 of them, 2 Oriental fruit fly quarantines in Santa Clara and Sacramento, and we're able to lift those quarantine requirements, which is the nice thing about fruit flies. With HLB, as you know, once we have a quarantine, USDA does not have an exit strategy for us. So always important when a lot of times these quarantines do overlap between fruit flies, HLB, ACP. So just always important to be clear on what the rules are for each, and we're here to help with that. So as far as the F3 dates for the other existing quarantines, they're assuming things keep going well, we're coming up on the end dates, hopefully, within the next couple months. All right, so HLB. Detections have slowed over the last couple of months, which is fantastic. We're still detecting them, but it's not at the rapid pace that we had been seeing over the last year or so. We were sitting at 70 positive trees in Ventura for quite a while, but somewhat recently had 3 more centered in that Santa Paula area. And still, the great news is 801 psyllids that are positive for CLAS out of the probably 650,000 psyllids that have been tested. So that's just such a ridiculously low number of positive psyllids carrying the bacteria, which is fantastic. So I know Sandra showed this. This is the quarantine. The last expansion was in January. Like she said, we continue to have HLB detections, but the spread has been limited, which really is largely due to the quarantine requirements to limit the artificial spread, and your and other growers and nurseries' attention to following the regulations has really played a huge role in keeping this where we found it so far, not into other areas where there's commercial citrus. Just wanted to show a couple pictures from tree removal activities in the Santa Paula area to highlight some of the work that Jennifer's team has been doing. There's a couple before and after pictures. Like Sandra said, once a tree is positive for HLB, we are required to remove it. So we do so either using a vendor, sometimes by our staff, and those trees we'll either double bag or chip and grind and take them to a landfill for deep burial. Of the 73 positive trees in Ventura, I think a little over 60 have been removed, and the remaining trees should be pulled this week to finish removing the reservoir of bacteria. We are continuing to survey in the area and throughout the county. But again, the HLB is still localized in Santa Paula, which is great that it hasn't spread. Okay, so some of the quarantine mitigations. Sandra, sorry, I think I'm going to let you down. I'm not going to go into too big a detail on the requirements like usual. Instead, I will give a brief overview and encourage anyone with questions more specific to your situation as a grower, packer, handler. Please reach out to us, and we'd love to work with you more directly to help provide the most accurate and appropriate guidance, since we know that there is no one size fit all. So mitigations are a performance standard. The performance standard is needed to move. The performance standard is to ship fruit free from ACP or HLB. These are all options that you can use to meet those requirements, to meet the quarantine requirements. We don't have any additional quarantine mitigations at this time. The main mitigations used are still the pre-harvest treatment, field cleaning by machine, which I know there's a few cleaning machines or stationary cleaning lines in Ventura, grate cleaning, and wet wash at a packing house, which is basically just running it through a packing house wash line. We have seen an increase in people using grates to clean and move fruit, and they seem to be doing a good job. If you're not sure about a pre-harvest treatment product or a mitigation method, please reach out to the county ag commissioner or to our staff. I would much rather we have the conversation prior to harvest and shipment, rather than a county at the receiving end or a different county issuing a notice of violation or rejection because the wrong product is used. We're really here to help. We want to make this as easy as possible. I know it's difficult, but as easy as possible on everybody, and to help facilitate business. Ethyl formate, the fumigation with ethyl formate, that registration is still in progress. The last I heard, I believe it should be available for use, or at least it should be registered hopefully this summer, if not early fall, and that should be a tool added to the toolbox for moving fruit. So we're really excited for that to help replace some of the pre-harvest treatments in the groves that are being done to help limit the interruption for beneficials, and just overall should be a good tool for us. So I will talk one slide about the actual mitigations to move fruit. I know Nathan, our local ES, has been getting some questions, so just want to quickly review the changes that went into effect last November, and with a minor addition in March as they apply to Ventura. So I tried to label these. I will share this with Maureen afterwards, but really, if you're moving it within the Ventura quarantine area there is no mitigation required. If you're moving it from Ventura HLB quarantine to the ACP or to another non-contiguous HLB quarantine, like in Riverside or San Diego, only one mitigation is required. And again, those mitigations are anything on that list. So we have some options. It's not required to be a pesticide application. There are other options for meeting that mitigation requirement. If you're moving it from Ventura to, say, the Coachella Valley or to the Central Valley, 2 mitigations or a wet wash is needed. And most recently, if you're moving it anywhere from any ACP quarantine into an HLB quarantine, there is no mitigation required. Because we're considered that from a lower risk area to a higher risk area. So again, please ask questions. Really encourage you to reach out to us. We would love to help for each individual situation. Okay, so we do have a few pictures taken by CDFA staff in the Santa Paula quarantine. Here are some lime leaves. These are from plants that tested positive for HLB in Ventura. And again, I'll share these with Maureen. So here are some lime leaves. And then here are some leaves from tangerine. I thought we had pictures of lemons, but we are working on getting those shortly to share with the group. But this is what some of the other pictures we had were of whole trees. So I wanted to make sure we highlighted looking at leaves that are expressing symptoms. And specifically in Ventura with your climate. All right, I wanted to bring up a few regulatory issues we've been seeing. The more awareness and outreach we can conduct, and the more I feel we can help prevent these things from happening. Not that I think people attending this meeting are the issue, but we at least want to talk about it and are very grateful for any tips or information if you see this happening in your area, or to help share this information and help educate others who aren't here. So over the last 4 months, I think we've 5 shipments of grapefruits from Florida have been intercepted at parcel facilities that tested positive for citrus canker. In March, we had 1 shipment of fruit and citrus trees from Florida that were intercepted in Fresno, and that tree tested positive for HLB. So fortunately, it was picked up by the dog team, or at least picked up by the county ag commissioner at the parcel facility. It was tested. We did follow-up survey and sampling at the destination residence. Samples were negative, so at least that's some good news, but obviously very concerning that trees are being shipped to California, which is not permitted by regulation, and especially more concerning considering it was carrying HLB. And then very recently, there was a sour orange tree that was intercepted up north that was tested positive for citrus canker as well. So we're seeing a lot of almost introductions through e-commerce. So it's becoming more of a concern. So we encourage people to buy locally, and appreciate any information or any tips you can provide to us, or to help any outreach you can conduct to your friends and neighbors. Over the last year, our teams have found 11 backyard or retail nurseries in the Los Angeles and Orange County area with containerized citrus for sale. Within the HLB quarantine, citrus is not eligible for sale unless it's maintained within an approved structure. Fortunately, none of these we haven't found any of these in Ventura yet. But we are on the lookout. We're spending time on social media and online marketplaces to look out for these types of residents and locations. Of the nurseries we found, 2 of the home nurseries were self-propagating, which is illegal in California unless you're using registered material. Total, we've placed a hold and destroyed almost 1,000 trees, including almost 400 at one residence, and some of those were trees that were shipped in from Florida. So again, very concerning for us. So yeah, we're going to continue scouting neighborhoods, following up on any information, looking online for sellers, and again, just know there's more out there that we're not finding. So any tips you have, we're happy to take and follow up on. Then lastly, again, a similar theme, roadside vendors. We know quarantine requirements are tough on you and tough on growers, but they seem to work and do their job to prevent the spread of HLB and other pests from where we found them. Our job is, as regulators, is to help make sure we don't let roadside vendors who move across the state ruin the good progress and work that you all have made in keeping HLB at bay. So, I know that especially during this season, we see a lot of them. If it's citrus fruit, it needs to be cleaned free from stem and leaf. if it's within a fruit fly quarantine area, that host fruit needs to be covered and safeguarded. And if it is grown within a quarantine area, a pre-harvest treatment and a harvest permit is required. Just Sunday, I had somebody from Cal Citrus Mutual. There was a grower who reported seeing a fruit vendor in the OFF quarantine and HLB quarantine in Riverside with a lot of fruit for sale. So they sent over a couple pictures, and we have staff who are following up on that to make sure that everybody is abiding by the same requirements as you all are. I think the only other possible change coming down the pipeline is USDA is reviewing and may amend their interstate shipping nursery requirements for citrus, but otherwise, that's all I have. We haven't had too many updates as of late, but we are continuing to try to improve and develop our program. Thank you.
Thanks, Keith. I have a few questions in the queue for you.
Sure.
What are the rules for non-bulk citrus shipments? Some companies and growers are doing online sales of non-bulk quantities less than 25 pounds.
So if it's so bulk citrus is defined as anything that's either commercial or being distributed. So it could be, we're definitely aware of, there's a lot of packers or gift packers who are doing small quantities or boutique type boxes, because that is still for distribution and for sale. The rules still apply to them. It's only, the exemption is only for, if you have a lemon tree and you're in the ACP quarantine and you harvest 10 lemons and clean them, there's no requirement for a pre-harvest treatment or a field cleaning or anything of that to move those lemons. So that's just for personal consumption.
Great. I know in one of our recent task force meetings, we had talked to you about putting together some resources for PCAs who are scouting. We really appreciate the photos that you shared. I know for me, it would be great to get some like one-pagers of, this is what tangerines look like, and every single photo you could possibly put on there, just as much information as we can. And obviously for all the different citrus that grows here. So I think it's an awesome start. One of the questions that came through in the chat is a local PCA asking that some of the leaves look like they might be indicators that the tree needs nutrients. And so how do you differentiate between a leaf that is indicating a nutrient deficiency versus a leaf that is indicating HLB?
That's a great question. Jennifer, if you have any information to provide, but basically for what our staff are trained to do is if it looks like it could be symptomatic, they collect samples. I'm unfortunately not going to try to advise a PCA on those kind of details when they're the experts. If there's concern, really let us know. But as far as differentiating between those symptoms, I'm not too sure.
So I'd like to open it up to questions from the audience in here. If you have a short question, just shout it out. If you have a really long, complicated question, please grab a microphone. There's one right up here, so I don't have to repeat your really long, complicated question and get it wrong. Any short questions? Lisa? What is the process to intercept trees that are being illegally imported into California? Is it complaint driven, or what does that process look like so that we can help participate?
So as far as The where we're intercepting trees are at parcel facilities or at border stations as they're being driven in. You know, counties have a lot of different dog teams that are looking through parcel facilities, as well as they have inspectors at a lot of the main hubs. But where we're struggling, I think where we're struggling a little bit is prior to that with people who are ordering the trees or ordering fruit from outside locations. And that's where we're trying to do as much as we can with the outreach to, you know, prevent that before it even gets to the parcel facility where people are ordering trees from Florida or from out of state.
Well, Lisa had specifically mentioned Etsy, so put that on your list as a place to investigate.
Will do. And to follow up on that question earlier about the one pager, I will get with our outreach contractor and see what we can do. I think that's a great idea. And we'll continue to try to get pictures. And hopefully we don't have any more trees in Ventura, but we'll continue to get pictures if we do.
Any other questions? Go ahead. Here, that mic's right next to you. Just grab that, like push that button till it turns green. Yeah.
Yes, good morning. Are there any universities or any research being done to mitigate these bugs through genetics? Or is anybody aware of such a thing?
I'm going to defer to the other very smart people here who may have more information.
We'll ask Neil when it's his turn. Yeah. We'll put that on the log for Neil because Neil's got an hour. All right. Any other questions? It makes me feel really good because that means that, you know, a few years ago when I started this, we had dozens of questions, which means that the information's getting out there. Derek?
Hi, Keith. This may be answered by some of the other speakers, but one of the points that's a takeaway is that this is a permanent quarantine situation. And I am kind of curious as the quarantine expands or potentially expands, is our list of psyllid fighting materials being looked at or possibly expandable? There are a very narrow range of very broad spectrum, very tough in the middle of the summer to apply materials. So question A is there any work being done at CDFA on new registrations or at the UCR level that you're aware of to expand this list?
So the only one I know that is being worked on is that fumigation with ethyl formate, but I believe Dr. Cass is scheduled to present today, and I know we haven't had much chance I haven't had much chance over the last few months to work with her, but you know, it would any new formulations or any new products to be added as far as insecticides would have to come from the recommendation of the UC and likely from Dr. Cass. Sorry to put you on the spot, but that's we as state agency are not able to make those recommendations or we rely on the UC for those.
Hi, Keith. This is Neil. The county ag commissioners through the ag gas tax fund paid for some work 3 years ago now that Frank Byrne did, and Frank rounded up all the likely products that he could think of that might have ACP activity and tested them all, and there wasn't anything hopeful from Frank's work at that time. So I'm guessing nothing new's come along since then. So I'm afraid bad news.
Thanks, Neil.
This is question B, and it's kind of adjunct to what Sandra was talking about with Doug Hill's grant testing, which I'm sure you're aware of by nodding. Yes, growers want to be the best growers that they can, and one of those is knowing where their pests are, period. At the same time, a grower is also aware that expanding potentially a quarantine zone is harmful to potentially some of his neighbors economically, and it's a huge decision. So that being said, Doug Hill has said to us growers a little bit who may want to find out if some of their trees within the quarantine zone or outside have HLB, that they can be tested and narrowed down. So I am curious. I'm going to ask straight up, if that tree is gone that they find, what happens next?
And you're saying if it tests positive through Doug's methods?
Correct.
If it, so since that is, and I've been working closely with Dr. Heather Martin, our state primary pathologist, on some permits for Doug. If it tests, and so under the permits, he is required to notify CDFA as a non-regulatory lab. But if it tests positive and the tree is gone, we cannot recreate that sample, we cannot establish a quarantine.
Just to clarify, Keith, could you walk through the steps? So, Doug comes out and tests, the test results come back positive. The CDFA and the grower are notified. The grower removes the tree. CDFA comes out to the field and then does what?
Right. So if I think it's within 24 hours is CDFA is required to be notified if there's a actionable test or if HLB is detected by Doug. And if the grower removes that tree prior to us getting there, we may try to sample other trees in the area. But I know with Doug's method, it's more of mass sampling. If we may try to sample other trees if they're symptomatic, but if we cannot recreate that positive, if that tree is gone, then we do, with an official sample, we do not have an official regulatory sample and a trigger to establish a quarantine and to impose quarantine requirements.
So, because I know we all want clarity. And the situation, CDFA shows up, there's a hole in the ground where the tree was. They look at the surrounding trees and through their discretion decide what to sample. If those samples come back negative, no quarantine. If those samples come
Absolutely.
back positive, yes, quarantine.
Yes.
Okay.
And
Is
we
that
are
clear?
working.
It's recorded, just so you know.
That's fine. And we are working with the citrus committee. One of the items we're looking at is the HLB detection response. Still high on the agenda is to evaluate the quarantine response and the implications of a quarantine. We have to get buy-in from USDA because we have to parallel their quarantine. But it is high on the list to try to, we are trying to, as much as possible, encourage grower participation and create avenues for that without harsh penalties. So that is something we're very aware of. We are trying to do within the scope of the framework that we have to work with.
Okay, we'll take a final question from Lisa.
Does CDFA, when they do a test, do they only require one test or does it have to be done twice, come up positive twice?
A single positive would do it. It does not have to be tested twice.
So no scientific method where you would have to repeat to make sure it's a positive.
And also not a statistically significant sample either, right? So, yeah.
Yeah, so what we would do is we would collect, if there's symptomatic trees or if there's whatever samples are taken, those would be taken to the CDFA lab, tested using the approved USDA work instruction. And if those came back positive, then yes, we would have an official sample. If those come back negative, we fortunately get to move on.
Right. All right. Thank you so much, Keith. Are you going to be sticking around if more questions pop up, or are you jumping off?
I can stick around for a while. I appreciate all your time.
All right, cool. Our next speaker is Amir from the Ag Commissioner's Office, and he's going to give us a update on the efforts in the county to combat ACP and HLB. Yeah, thank you, Amir.
All right, good morning, everybody. My name is Amir Atrash, and I'm the Deputy Agricultural Commissioner in Ventura County, responsible for the Agriculture and Consumer Protection Division. And pretty much I manage the ACP HLB efforts in Ventura County. So first off, I want to thank Maureen for allowing us to be here. Thank you, Keith, Cressida, and Sandra for all the work that you do. And I'd like to see if I can spend some time talking about the local efforts that we do at the county level to help with compliance, enforcement, and all that other stuff. All right. So that's a silly. I do know that a lot of you all here in this room are very educated and very knowledgeable of the quarantine. So I don't want to focus too much on the background of it, but I felt that it would be a great opportunity to reach out to more people, especially since we have the Zoom going on, to focus on outreach along with the compliance efforts. So obviously there's the ACP-HLB quarantines that we have that, there is distinguishing between the two to kind of figure out how we do our compliance efforts. And so focusing on compliance efforts, I can go to the next slide. The main focus on our end is we're looking to start off the compliance pathway with the compliance agreements, right? So our main focus is focusing on grower compliance agreements along with transporter haulers, packers, and fruit sellers. And, it kind of covers everybody in between, right? So depending on each compliance agreements, there's very different rules and regulatory items that need to be followed. So it's really important that we communicate with that. So what I'd like to focus on for the declaration forms on ACP is we all have seen these. I know a lot of us in this room have seen these forms, but at least in Ventura County, I want to be able to focus more on the outreach of making sure that these are sent to our office and also to destination offices. I'm new to the program. I've been able to kind of see the program with a different lens, and we've been able to see that unfortunately some of our ACP free declaration forms haven't been sent in for growers. So I'd really like to focus on the education part of it to kind of do the outreach and say that I'd really appreciate if we can work together and get these declaration forms because it helps us do our job. It helps us reduce the spread and also hopefully, mitigate the efforts of HLB and ACP. And then also the, I don't know what I was going to say, MLB, HLB. So the mitigation forms for HLB, obviously a bit different. So there are different items that need to be followed. So I think Keith talked about it really well. What needs to happen going from zone to zone, especially from HLB to non-HLB and kind of back and forth. We just kind of put an example of what the form looks like, along with the table that's in CDFA's webpage that talks about mitigation methods and how to move fruit from where and giving examples on where to move it. And again, just kind of going back, sorry, Maureen, we really want to focus on the mitigation forms and the ACP declaration forms, really helping us out with the growers because the responsibility is on the growers to send those in. So if you wanted to work with your packing house or whoever you work with to send those in, that's completely fine. But the majority of it is really getting it to our offices. So some key items to protect our citrus, kind of as a caveat, I put key items because you want to look at the ACP and HLB compliance agreements to get the full details. But these are some key items that we're looking at to protect our industry with the enforcement actions that we move through. So moving bulk citrus, a really important part is anytime you're moving bulk citrus out of an ACP regional quarantine zone, there's certain mitigations that have to be met. So obviously we have the spray and harvest, the field clean, and then we've also had some great methods used here in Ventura County that have been approved by CDFA. So it's really about working together to be on that path. Now, another part I want to focus on is the grate cleaning. It's really important that we work together before you all start using this method so that we can see what that method looks like and have it approved. Depending on how things work, knowing that we have an HLB quarantine in Ventura, there's fruit meat being moved inside of that HLB quarantine outside to, let's say, a packing house in Ventura. That's a different, unique setup. But then you also have fruit moving from outside of Ventura County to other counties. So definitely we want to be able to work through that, get CDFA involved, get the destination counties involved to make sure that we're involved with creating a good contractual agreement with the Great Clean. Now that's just for the Great Clean. Again, declaration forms and all that stuff is really important. And it's also really important to have all records available. So as I'm looking into the program, I want to work with our staff to kind of move forward in a direction where we can help with mitigating the pests along with doing our enforcement actions. The more information that we can get, the better for us to help out with the entire system. I definitely understand that it can be a challenging and you know, very hard way to kind of work through getting those items. And we understand that, but we're trying to work together. So I'd really like to focus on working together. And it's not about us just jumping out there. It's about us working together on this. So I'll break it down a little bit into grower inspections, transporters, haulers, you know, everything. But the majority of, at least for the grower inspections, is being able to ensure that partnering establishments are all under compliance. So this is something you're going to see across the board. So everybody kind of has to check everybody, right? So we want to be able to help each other in understanding that we're all compliant. So if you're a grower, you're reaching out to a packer, it's important to make sure that your packer's in compliance, right? You know, if you have a transporter that's coming to your grove or to your field to do a harvest, it's really important to understand that your transporters are in compliance as well. Pest mitigation methods. So this is something that you'll see on the ACP free declaration form. So it's just important to notify our office and let us know exactly what method you're choosing. And if you do a spray and harvest, I don't have it here, but in the other example, there's some line items for it. But if you can also include the spray application that you're using for that method. And a thing that I forgot to update to is especially with a field cleaning method. So notifying the origin county 72 hours in advance is a very important key point to making sure that we're successful with this, and the destination county 24 hours in advance. Now, a major focus of what we do in the county is for transporter inspections. And at least from, I think, January up to this date, we've had over about 200 plus inspections for transporter inspections. And we've been noticing a very good turnout of people doing tarping and safeguarding really well. So we really appreciate that. And I think that's a great example of how we work together to really mitigate this pest. So just wanted to show some key examples of what's good tarping and what's not sufficient tarping. So when you have a load that's completely full or like it's an enclosed truck, amazing opportunity for us to make sure that that pest is mitigated, right? Then hopefully it goes to the packing house, does its field clean, washing, brushing, all that stuff to hopefully knock out the pest, right? Unfortunately, at the bottom, when you have tarping down the truck bed, or if you have an open truck bed with, you know, citrus fully exposed, that doesn't mitigate the pest, and it leads to a lot of challenges. So we really appreciate working together to have a complete tarping. No, you're fine, Maureen. So I do got a lot to say. You know, the other thing too about transporters, and obviously this is a grower meeting, so I'd really appreciate if you can communicate this with your transporters, is notifying them that the ACP free declaration form must go with the shipment. So it's really important to have that, because once we're at the packing house and we do these inspections, we're looking for those documents. So I would really appreciate you as growers communicating to your transporters to ensure that they have the ACP free declaration forms or the HLB mitigation form. And packing house inspections. So packing house inspections are primarily more of a records check to make sure that we're understanding that the citrus is coming in. What we would like to do is get out there, look to see what kind of records we can go through to make sure that all of the citrus coming in is under compliance. And I would like to start off, you know, this part with, you know, reaching out to the packing houses. And if we do, if we are able to catalog and see who, you know, might not be on compliance, I like to focus on the educational component, reach out to make sure that they are on compliance with the compliance agreement and moving in that direction. Another thing that's really important with the packing house inspections, which kind of connects back to the growers, right, is the leaves and stems, right? So when we're looking especially at field clean by machine, or if we're looking through the great harvesting system, we're looking to knock out the stems and leaves in the load. And it's really important to have a very, very minimal amount of leaves and stems. So as inspectors, I definitely have my staff out there, and we're doing these inspections to see what the amount of leaves and stems are coming in. And from what we've been seeing so far, it's been very minimal, so I appreciate that. But that's just kind of the efforts that we're doing in our office. A little bit about farmers markets. So farmers markets is unique, obviously, because it's more so fruit coming directly from the field to the farmers markets, but also there is a fruit sellers agreement. So in that fruit sellers compliance agreement, they're obviously required to do certain mitigation methods. So we follow through on that. And on the next slide, I have some more, Maureen. So obviously, a certified farmers market cannot accept fruit from a grower that's not in compliance with the program. So it's very important for us to outreach and communicate. So if you're working, at a farmer's market, or you have staff or employees that are harvesting from your ranch to work at the farmer's market, please ensure that you have a compliance agreement and they have it at the field or they have it at the farmer's market. Obviously, they must follow all the quarantine zones and stuff like that. And fruit must always be safeguarded in transit. So some common violations that we see. Definitely compliance agreements. That's a huge part. Now, obviously, compliance agreements are, I would say, a lesser violation that we're concerned about, because most of the time when we do these, we see that companies are in compliance. They just don't have the paperwork with them. But a major part is if we find out that you are not in compliance with the program, we would like to get you in compliance with the program. So a lot of it is focusing on education. Obviously, there is an enforcement component of it, but we like to focus on the education and outreach first. ACP free declarations not being submitted. So again, that's something that we talked about earlier. Having those in the truck is very important. So that's a common violation. Fruit not properly tarped when transported, or fruit not properly transported. I should have put tarp. But yeah, when it's not tarped or when it's not safeguarded, that's another common violation. And then the leaves and stems. So making sure that those are knocked out. Green waste, I'll talk just a little bit about. The main component about green waste is ensuring that it's safeguarded. Obviously, there is a need for green waste and how it's processed, but when you move it, just safeguard it. And yeah, there are exemptions for fully processed and packed and juicing, but a lot of it's really mixed into the compliance agreement. So I would look into that. And then outreach, kind of wanted to end on that a bit. So on the outreach component, just some of the outreach efforts that we've done very recently are the Ventura County Fatherhood Summit, where we were out there spreading information about our department, but also spreading information about the ACP-HLB program, mitigation methods, and what people can and can't do with their trees. We definitely participate in Farm Day. We actually I think that same weekend, last week or 2 weeks ago, we were at the Oxnard Insect Festival. We've definitely participated at the California Strawberry Festival, Ventura County Fair, and we're also at the Swap Meet Justice. So on a different component of ACP-HLB, which we also do share that input. At the Swap Meet Justice, we're there to do some outreach on pesticide use and kind of what to look for, how to be safe and stuff like that. And we're looking at trying to get a little bit more involved in the Santa Paula Cruise Night. So a little bit of outreach. But also on that note, I did want to ask you all for some help. So I really want to focus my job on being more effective at outreach and sharing more information with the public. And if you all have any resources, and we can go to the next slide, I'd definitely love for you to send me that info. So my name again is Amir Atrash. That's my email, amir.atrash@ventura.org. Phone number at our Camarillo office is 805-388-4222. And then to send in declaration forms or any kind of information where you want to get some answers on the ACP bulk citrus program, you could send it to that email right there. It's acpbulkcitrus@ventura.org. But as far as like any outreach or anything specific that you really want to reach out to me personally, that's my email and I'd love to help out. But that's kind of our efforts in Ventura County, and I'd like to take any questions if anybody has any.
Yeah, thank you so much, Amir. It was a great day when a bunch of Ag Commissioner employees came to my office and got all the Save Our Citrus stuff from my back room. to use at the 150th event. And I know your outreach is working because I get calls from people with backyard citrus trees all the time looking for resources. And so really think it's a cool part of the program that you guys have incorporated along with CDFA to let people know what they can do to protect commercial citrus. One
Right.
of the questions I wanted to bring back is if you had any comments about that question about the mailed less than 25
Sure.
pounds.
As far as the 25 pounds, I think, Keith had touched on that a lot better than I could. I think it's more of a regulatory component. But what I can talk about is our efforts at the terminals. So when we do inspections at UPS, FedEx locations, we have inspectors out there daily doing inspections on packages coming into our county. Obviously, we do as much as we can with the time that we're there. So we're looking for agricultural products, anything that looks suspicious for us to do inspections and make sure that we can intercept those packages. And if we do find citrus or if we find anything that may be breaking any kind of quarantine laws or regulations, which are other commodities as well, we have the authority to place a hold on that item, or we have an authority to dispose of it, or choose other disposition methods where we send it back to the grower or the shipper. But we're definitely making sure to do that interception as much as we can. Yes. That's a
Make
good
sure you
question.
repeat the questions for our online listeners.
Oh, sure. I think the question was if we have any data in Ventura County to share what the statistics are of how many people or how many growers are using spray methods as opposed to field cleaning. I don't have, no, I appreciate that. I don't have that information on hand. I am working with our inspectors to kind of revamp some of these data collection methods that we have in our office, but I'd love to get back to you if you can share some information, and then maybe we can share that with everybody else.
I have a couple online questions for you. Is GWSS compliance doc still required, or does HLB compliance doc cover it or supersede it?
That is a good question. So GWSS, standing for Glassy Wing Sharpshooter, and ACP, Asian Citrusilla, are two different programs. So unfortunately, GWIS will not cover that. They're two different programs. And fortunately, I manage both. So if you have any questions, my email was up there. Please contact me directly so I can help you specifically if you had that question, so we can make sure that you're in compliance and help you out with that.
Within an ACP quarantine zone, does each load moved from orchard to packing house require an individual declaration form?
From each packing house, move to each packing house. Can you
No,
repeat the
from
question again?
each load from orchard to packing house.
Got it. So it really depends. So obviously with the ACP declaration form, it's utilized for the movement of citrus from one regional quarantine zone to another. So hopefully to answer this question, if it's moved within Ventura, not HLB, but if it's moved from, let's say, Oxnard, which is not HLB, to Ventura, which is not an HLB area, does not require a ACP declaration form. Now, if you're moving fruit from, let's say, Ventura County to Monterey County, then you do need an ACP free declaration form. Now,
Is
it
that
should be
per
with each
load?
It should be with each load,
Mhm.
but we are working with growers, especially who have a high volume of citrus, to work on a range. So for example, if you're picking Monday through Friday, you have 150, 100 bins or whatever the case may be, we'll work with you independently to understand that range, right? And we don't need it per se every day, but if you send it on a Monday, if you send it on the Friday before for that week, at least we're identified to understand what your shipping is going to look like. So if we need to get out there, then we can do the inspections at the field. Or not at the field per se, but well, at the field or at the packing house.
So Keith answered your question, Dr. Cohen, that on the statewide level, which isn't broken down to Ventura County, about 60% of the mitigations are spray and harvest.
And thank you, Keith.
Any more questions from the audience? All right, awesome. Well, Amir is ready to serve and excited to connect with all of you. And thank you so much for all the work you're doing here and for speaking with us.
Thank you. Thank you, Maureen, and thank you, everybody else. I appreciate it.
It's really
Awesome.
good to be back in Ventura. I always like driving down 101 when you hit the coast. It just feels like, oh, okay, this is how life's supposed to be. So I'm gonna give you an update on research. I'm gonna mainly feature work by three colleagues. Wakey, some of you will know, is based on the East Coast, but he's been providing support to the program in California for a long time. The risk-based survey models that are used to drive a lot of the surveillance work that goes on originate with Wakey and his old boss, Tim Gottwald. And then Dr. Sandra Olkowski is a program manager in my group who's worked on citrus for a long time. She spent a year in Visalia working for CRB a few years ago. Her background is in vector biology, and that's going to be important in a little while. And then Victor Alves is a PhD student in my group too. So I'm going to mainly talk about stuff that those three people have done in conjunction with me. But before I dive into that, I'm going to answer the questions that came up. So there was a question about genetics. If we're talking about the insect and doing things like have been done with mosquitoes to make them incapable of carrying things like dengue fever or malaria, that was looked at 8 years ago. And it turns out that there are really simple but sort of insurmountable challenges for doing genetic transformation with ACP. The eggs are really, really fragile. And so when you try to inject the genes that you want into the egg cells, the eggs burst basically. And so the group that was working on that was never able to get a successful transformation for a really kind of simple, kind of almost silly reason. But the prospects for playing around with the vector to make it incompetent to spread the bacterium are not good. And I don't think that work has been pursued since those days back then. On the tree side, things are much more promising. Particularly in Riverside, the group there have made some progress breeding in resistance from wild relatives. Of course, all the citrus that we eat is from a fairly narrow set of genetic backgrounds. And it was no surprise when they started looking at wild relatives and citrus that's non-edible. There are sources of resistance out there. It's a long process, but already there are some more tolerant types that have been released, both in Florida and California. And so the long-term prospects are pretty good for us having, if not complete resistance, at least genotypes that are more tolerant of being infected. So long-term on the tree side, things are looking good, but I wouldn't hold out any hope for something on the insect side anytime soon. Question about trade of illicit material. Keith gave you some of the background on, and Amir too, on what happens. I'm going to say a little bit about a bigger project that's going on. I'm not going to say too much, but the ag commissioners have been incredibly proactive in trying to update California's entire pest exclusion system. And through the Division of Plant Health and Pest Prevention Services, which is where Victoria is now the director, they have commissioned a project through my group to coordinate a lot of different programs and projects for the state to have a comprehensive overview of the way that California tries to keep bad stuff out. And specifically in relation to trade of plant material that shouldn't be coming to California. At the county level, the ag commissioners do inspections, but they also work in conjunction with Customs and Border Protection for stuff that's coming from outside the US, and then with USDA APHIS for stuff that's moving around inside the US, and specifically in relation to trade of plant material for planting or fruit material. There's a group within APHIS called SITC, S-I-T-C, Smuggling Intervention and Trade Compliance. Is the name of that group. And they have a specific e-commerce group unit, which is looking at ways to prevent either unknowing or deliberate misuse of e-commerce as a means of getting stuff into places where it doesn't belong. So basically, my team has all of the the data for as much as can be generated, but from intervention practices at postal stations and package handling facilities. And at the end of the year, we're hoping that we'll be in a position to prevent a kind of comprehensive overview of everything that the state is doing to keep bad stuff out. And at some point, that will be made public in some form. I can't say any more about that at the moment. It's a pretty huge project that involves a lot of moving parts, but just want to let you know that it's something that's being actively worked on to try and improve the situation. Okay, excuse me, I've got a frog in my throat this morning. Okay, can we have the next slide? I'm going to take, to start this, I'm going to take an historical perspective, because it occurred to me that I've made the drive down from Davis to talk to this group many, many times, and things are very different this time than they've been on most previous occasions, and particularly some of the early events that we did. And I'm really pleased that Mark is here from Riverside, because some of what I'm going to say today and his talk, and I think Bo's presence here also, are indicative of the way that the science has moved on from how it was in the early days. And this group has been really important in driving the agenda in the way that we've changed our perspective on things. So I'm going to take a historical perspective, and then I'm going to tell you my view of what I think the current situation is in the state. So kind of go back over a little bit of the ground that Sandra covered. And then what's our current thinking on how HLB might play out in California, particularly with a perspective on Ventura, and kind of lay out how I think we can afford to be a little bit more relaxed about the problem than we were in the past, and take a more balanced approach to management of it. But it relies on us having some key biological insights into this thing that we just didn't have a decade ago. Okay, so kind of a new update, and hopefully some good news for everybody, because I know you've got other things that you want to be worrying, well, you don't want to be worrying about them. You have other things that force you to worry about them, and not having to think so much about HLB would probably be a nice thing. Okay, so let's get going with the historical perspective. So next slide. I'm going to take you back to early December 2015. And this group met in the County Museum in Ventura. And here's the draft agenda. I couldn't find the final agenda version, but John Christ emailed me a draft agenda and said, is it okay if, does that look okay to you for your part? And I said, yep, that looks good. So on the agenda that day, the three experts who were talking to you were me, not too long in California at that point, David Bartels from USDA APHIS, and Mike Irie, who was the research manager at that time for Southern Garden Citrus in Florida from American Sugar. Okay, and so Dave and Mike and I did a little bit of a mini roadshow that winter, that early winter, and I picked Dave up from Sacramento Airport 2 days before we came here, and drove him down to Visalia, where we did a grower meeting in Exeter, if I remember right. But Mike and Dave and I had been emailing back and forward once the program for those talks was finalized, and basically agreed, without actually saying it straight up, that the most important, and Beth was in on this, although she wasn't at the meeting, the most important thing was to keep the level of anxiety as high as we could, because we were worried about what the future might look like. So the tone of the talks on that day was that if we didn't all do everything we possibly could as quickly as possible, the sky would fall on our heads and California would look like Florida 2.0. Mike said it from his experience as a grower in Florida. Dave Bartels said it. Dave had just started to look at the way that hot ACP from the surveillance program tended to occur in clusters, and he was thinking about the idea of using that as an early detection method for where there might be hot trees. And that's one of the few ideas that has survived intact from 2015. It still actually is a good way of working out where there might be infected trees in the landscape. It's really hard to find them, though, even if you know where the hot ACP are. So we should all pay tribute to Dave for having that insight. But one of the most important things that happened back then was that out of the discussion of the need for area-wide management and more local information, the idea of having a scout for Ventura grew out of those discussions. And then John approached the packing houses to put up the money, some checks were donated, and Joanne was employed to start scouting for ACP at 50 commercial locations around the county. And that little project led to Beth and I applying for a MAC grant to blow that work up to a kind of coastal California scale. Joanne continued on the program for Ventura, but we brought on sites for Riverside and San Diego as well. And that MAC project led to another MAC project that Monique and Frank and I put in for. And so we had a period of about 5 or 6 years of continuous research focused here, specifically looking at questions that were important to this area. And all of that work generated some really useful insights, and the PCAs and the members of the smaller task force group had opportunities to input to that work. And if we jump forward to the summer of, I'm going to say it was 2022, Sandra, when you asked Mark and I to talk in Riverside after the first quarantine area blew up. So Mark and Ivan and I gave some talks in Riverside and then in San Diego, similar to this idea, same agenda each time, but different speakers. And it was the first time Mark and I had a chance to hear each other talk for a while, and we compared notes about our changing perspectives. And out of that conversation, the idea that, yes, the things that the growers were pushing for, PCAs were pushing for here in Ventura, a more traditional IPM approach, perhaps would work for ACP, even though we're more worried about it as a vector than as a pest. And the traditional thinking from plant pathologists on vector biology is if you've got a vector, your threshold is effectively 0, particularly for a disease which could do the kind of damage that we had seen in Florida. But as we continued to tell you that story between 2015 and now, things continued not to happen as we had thought they would. And so we were asking questions on the epidemiological side at the same time as Mark and others were coming up with some really nice results about the potential potency of a mixture of introduced biocontrol and natural enemies, learning how to handle ACP as a source of food. So I'm going to not say too much more about all of that because I don't want to stray into territory that's going to be better covered by later speakers. But if we could move to the next slide. So this was the picture that was in everybody's mind, even if you hadn't seen the actual picture. This is what happened or was happening to Florida at that time. And HLB isn't responsible for everything that you see there. There are hurricanes having an impact on production too, and also citrus canker. But that precipitous decline in the last 8 or 9 years of that graph, that's largely down to HLB. And that was the sort of thing that people didn't want to happen here in California. You have to bear in mind that at the time when we were selling that story, this disease complex had never invaded a Mediterranean climate anywhere else in the world. All of the reported HLB epidemics in Florida, in Brazil, in the Caribbean, in other places in Asia where the disease had turned up, they were all in tropical or subtropical climates. So all of the evidence that was available was that this was the kind of thing that happens when HLB gets into a citrus production area. That was the best guess we had to go on at the time. Okay, so if we move to the next slide. So our model of what happens with HLB was something like this. There are healthy trees. The insect comes, the adult insects come with the bacterium, they infect the trees. The trees spend some time when they're infected, but not visibly infected when they can infect other insects. The trees become infectious after a while when the bacterium breeds. Then they turn symptomatic, and all the time between when they're infected and when they finally turn symptomatic, the psyllids can be picking up the bacterium it multiplies in the psyllid, and then the psyllids fly away and spread it to other trees. That was how people thought the disease works. It doesn't actually work like that. The mechanism through which the bacterium gets from one generation of psyllids to the next can happen without the tree becoming infected, because the bacterium can be picked up just at the local point where the adult females feed and lay their eggs, and their offspring feed. Okay, that's both good news and bad news from our perspective. The bad news is, and this is how we worked out that this couldn't be how it works, because sometimes the infection can spread much faster than can be accounted for by waiting all that time for the tree to become systemically infected and then the bacterium being picked up. So we worked out that that couldn't be how it was working, or at least not all the time. There had to be a more rapid way for the bacterium to get from one generation of infected adults to the next. And they can spread it more or less directly to their offspring by feeding together in the same place locally on the tree. But that local infection, which can cause one generation to get infected from the next, doesn't necessarily lead to the tree becoming infected. And work, which I'll show you in a minute or two, work that was done in Brazil between 2015 and now, actually worked out that the bacterium is pretty strongly affected by the ambient temperature that the tree is in. And when it's too cold or too hot, the bacterium doesn't actually move very effectively in the tree. It just kind of sits where it's introduced. And then, of course, there's always the possibility that those leaves will fall off, or that you'll cut them off when you're hedging or pruning, or that the bacterium will just sit there without moving too far, and the temperature will never allow it to become systemic. So we don't know for certain that that's what's going on, but we strongly suspect that that's playing a role in why we're not seeing such massive spread of the disease in California. Okay, the other thing that we know now that we didn't know when this was our idea of what happens is that the psyllid is much more likely to become infected and to become infectious as an adult if it picks up the bacterium when it's a nymph. Okay, adult psyllids, if they're healthy and not infected with the bacterium, don't actually acquire the bacterium very easily from infected trees when they feed. Okay, we're not exactly sure why. We suspect it's got something to do with the development of their immune system as they age from being nymphs to adults. It's not impossible for them to become infected, but they don't pick up the bacterium as easily, and they're not as infectious if they acquire it as adults. So the real source of danger is eggs that are laid on infected trees or from infected mothers, which get infected as young nymphs, and the bacterium's inside their body from early on, and it multiplies inside their body the whole time they're developing. And when they turn into adults, they've got the biggest chance of being really infectious. And then they fly away and they spread the disease. But the whole time that they're on the tree they're born on, they're stuck there. They can't move, they don't go anywhere. So even if they will eventually turn into infectious adults, there's a period of 3 weeks or so when they're on the tree they were born on, they can't move, and they're available for predation and parasitism, or to be killed by environmental conditions, a heat flash, cold nights, whatever. So the vector is vulnerable as a vector for a period when the juveniles are stuck on the plant they're born on. And that makes it quite similar to other diseases that we know about. For example, anybody who grows tomatoes might see tomato spotted wilt virus on their plants in the summer, which is vectored by thrips, western flower thrips. They have an even tighter control over when they can become infected or not. Only the juvenile thrips can get infected. The adults can never acquire TSWV. And that means that the management has this little window every generation where you can stop the disease from spreading by killing the juveniles, which is exactly what many of their biocontrol agents do. So things are starting to look a little bit more hopeful for us, right? It's not a classic continuous infection vector type situation. The vector biology isn't isn't how we thought it was simplistically back at the beginning of all of this. And I'm going to show you some data collected right here in Ventura during one of those MAC projects that shows that process that I was just talking about actually happening. So if we can have the next slide. So,
Really quick, Neil.
yeah,
When was ACP first detected in California?
in 2009, I believe, 9 or 10. August of 8? Oh, thanks, Georgios. I'm 1 year out. Okay, so let's move on to then, with some of that background, which we're going to come back and look at in more detail, what's my perspective on the current situation in California? So if we can have the next slide. So the information I'm going to show you here is available through the agenda items for the Citrus Committee on the CDFA website. If you go to the CPDPC committee meeting webpage at the CDFA website, you'll see that on the agendas, there's always supplemental material PDF, and that contains all of the information that's going to be talked about at the committee meeting. It has to be there in compliance with the Bagley-Keene regulation. So you can always go and find this information if you don't take it in today. The current situation, as far as we can look at it in the state, is that we have a worrying increase in the numbers of infected trees and also the numbers of infected psyllids, right? We're well over 7,500 infected trees now. Multiple counties are involved. There are, as Sandra pointed out, multiple quarantines. But if you look at the data broken down by county, the overwhelming majority of where the really bad things are happening is focused in Orange County. So Orange County alone accounts for the majority of all of the recent detections of infected trees and the bulk of any really hot infected psyllids that are happening. So we really have, I think, two distinct epidemics going on in California at the moment. There's what's happening in Orange County, which is worrying. And then there's everywhere else. And everywhere else still includes Ventura, even though there's an active quarantine here now. So when you look at the headline figures for what's happening, bear in mind, and you can go back and look at the data in more detail, that the really hot area is this big infected cluster in Orange County. And that probably represents an historical early infection or multiple early infections that just took a randomly long amount of time for the program to detect. It doesn't necessarily indicate that there's a lot of spread happening there. Some of those detections could well be plants that were infected many years ago. There's a question at the back. 100% residential, everything's residential. I think I'm right in saying there's 0 commercial acreage in Orange County now. So we have a huge hotspot centered in Orange County that is the source of a lot of the data that is driving perceptions about how quickly the disease is spreading in California. If we go to the next slide. If you're interested, you can see that in more detail here. So for example, if you look at table 3, the percent of positive samples per county, because the surveillance program is mining its way through a very large hotspot in Orange County, 70% of the tree samples that were returned from Orange County were positive. That's a very high percentage, indicating that most of once they find an infected property, most of the other citrus around that property are also infected. Okay, 60% of the ACP collected in that area are infected. That's way higher than the statewide average. Okay, it's an extremely hot patch. So, but that's the only place that it's like that. Even the LA hotspot, which is a few miles to the north, isn't as hot as the Orange County hotspot. So there's some encouragement to be taken for the fact that it's relatively unique, but there's also a really severe warning sign for us there, particularly when we come on to look at how bad to what extent what we're seeing there might be the tip of the iceberg. Okay, and I want to talk a little bit about some work that Wakey's been doing to try and work out how much of the iceberg we can actually see. So a mixture of good news and bad news, but everywhere isn't Orange County, I guess, is the take-home message here, as bad as that is. Okay, next slide. So here's the sort of data historically showing detections, and here they're scaled so that the detections fill up the bar chart as much as possible. So the scales differ on the vertical side, but you can see there's your 73 infected trees that pop up in the last year in Ventura in the bottom right chart. But you can see that how much more recent that epidemic is compared with how far back in time the LA and Orange County and even Riverside epidemics go. So 73 trees here is definitely a warning to everybody that there's not zero risk, but it's a long way from the thousands of trees that are being detected in Orange and LA, and Orange in particular. My take on this is that there's still every hope that the situation is and will remain manageable in Ventura County as long as the community as a whole remains active in pursuing bearing down on this thing and making sure that we don't get too complacent about it. Okay, next slide. Okay, so Sandra's been looking at the data from the program for the psyllids because we're worried about them being able to spread the bacterium. And so when the lab gets psyllid samples, it runs the PCR test, and the PCR test generates what's called the CT value. And the CT value is basically the number of cycles that the PCR machine has to go through before the concentration of the bacterial DNA in the sample gets to be big enough that it triggers the machine to say there's a positive. And obviously, the more DNA you start with, the quicker it gets to that threshold. And so the lower the CT value is that tells you you've got a positive. So low CT values equal high levels of bacterium in the sample. So if we're worried about the psyllids getting hotter, when we plot out the distribution of CT values, again, what we're worried about is seeing that graph move to the left. Okay, so we've split all of the available data from the program into two groups. The left-hand graphs show the CT value distribution for everywhere except Orange County, and the right-hand graph shows Orange County. Okay, so that's what the two panels represent. And then you'll notice there's two kind of distributions within each panel, and those represent before and after a cut point that we generated. And the cut point was a date a few months ago when our constant re-analysis of the data as it comes in indicated that the surveillance program detection rate had accelerated. The model that we'd fitted, the line essentially that we'd fitted for every month before that suddenly didn't fit the data anymore. And we had to introduce a breakpoint in the line to make it fit the data. And that's an early signal that something is changing. So the pink color represents the distribution before the cut point, and the blue distribution represents the data from after the cut point. Okay, so the cut point is when the epidemic noticeably started to accelerate. And you notice the data from outside Orange County on the left-hand panel, the two distributions are essentially identical. Okay, there's no statistical evidence that the psyllids anywhere outside of Orange County are getting hotter. Different story in Orange County. You can see that the blue distribution has two peaks. So there's cold psyllids and hot psyllids. And the hot psyllids are getting hotter, and the distribution is starting to move apart. And it's starting to look less and less like how it used to look, which is the underlying orange distribution. So here's the signal. This is what it looks like when an HLB epidemic starts to get out of control, and the psyllids start to get hotter and hotter because more and more of the trees that they're visiting are infected. Okay, so we're starting to get that unwelcome feedback between the infected trees and the infected psyllids. Okay, so now that we've seen this, we know what to look for. So obviously we can keep our eye on the data being collected from everywhere else and checked and hope that we don't see this kind of thing develop in other places too. Mark? Yeah.
Make sure you repeat that question for our online listeners.
Mark,
And if you're going to ask really long questions, we have a microphone
Mark
available.
asked a long question, which I think I can remember most of. So the first question, the first part of Mark's question was, looking at the panel on the right for Orange County, is there statistical evidence that the blue distribution is different from the orange one? And the answer is yes. If you test that, those two distributions are unlikely to be the same by chance. Okay, so blue doesn't equal red on the right-hand graph. The same test, blue is indistinguishable from red on the left-hand graph. So that's the first thing. The second thing was a question. The second part of the question concerned the kind of underlying biology of why it might be starting to look like this. So does it indicate that the idea that local infections on trees only are driving the dynamics? Does it indicate that the trees are probably more systemically infected? And if that's the case, does that mean they're easier to detect, and also that the psyllids are more likely to acquire the bacterium from them? And the answers to all of those questions are probably yes. It's hard to know for certain, but that would certainly fit what we're seeing. That would explain all of the observable facts. Okay, let's move to the next slide. So one of the important questions is, okay, the program can't look everywhere. In general, the surveillance program visits about 1,000 square miles a year, 1,000 STR squares across urban Southern California per year. And so here's some actual data from the surveillance program. So the dark colored dots represent properties that could well have one or more citrus trees. And the red dots represent places where surveillance actually happened and detections were made. Okay. Now, if we focus on the yellow square, which is out of place. So the yellow square should be 1 square mile to the north of where it is. Okay. In a square that doesn't have any red dots in it. Okay. Sorry about the confusion. So in your mind's eye, move that yellow square one row up to the square above, which is a completely healthy square, okay? And the question is, okay, we can't look everywhere. Given that we can't look everywhere, how many infected trees might there be in that completely healthy square mile where we haven't been able to look? That's the question. How can we answer that question? Well, we can answer the question by looking at what we know about the squares where we did find infected trees, and then making some assumptions about how likely those squares are to perhaps act as sources of infection for the squares that we don't know about. So that's the basic idea, right? You take what you do know and you apply what you know to the squares that you weren't able to visit, and you extrapolate from there. And you can then decide how conservative or not you want that extrapolation to be. Okay, so that's what Wakey's been working on recently. So give me the next slide. So that's just illustrating this idea, okay? Like, what's the influence of the neighboring square miles where we know that there are infected trees? So move to the next slide. Here are the results at the edge of the Orange County, LA hotspots. So those red squares represent Wakey's estimates of the maximum possible prevalence of infected trees, the ones we can see plus the ones we can't see. Okay, just to illustrate that we can do it square mile by square mile. But if we move to the next slide. Okay, so here's the bad news. Okay, so how many, Wakey calls them hidden HLB trees, might there be in the landscape? So if we just go with the data and consider that to be our most conservative estimate, what Wakey calls the minimum here, but that's not really an estimate, that's just the observations, okay? Then based on that figure, we think at the end of last year, there were probably as many as 24,000 infected trees in Orange County at that point. That's the second row, which is about 4% of the whole population of urban trees. Worst case scenario, that figure would be as high as 36,000, which would represent over 6% of the population. The bottom line of the table represents Ventura. So at the end of last year, let's just call that recently, we know there are 73. We think there might be 87, best case. We know there are 73. We think there might be over 100. But we're still close to the actual observations at this point. Okay, so it hasn't got away from us, is the good news. Even by being fairly, taking a fairly kind of Pollyanna approach to how many trees there might be out there, we're still only barely over 100 estimates. So it's not by any means time to throw up our hands and say it's got beyond us. OC is a different story. I'm not sure that is a viable, there's a viable prospect of maintaining any kind of control there. But that's not a decision for me to make in any way. If we can move to the next slide. Okay, so I'm going to wrap up with some good news, some stuff that we've been putting together that shall hopefully lead into things that Mark's going to say, things that Bo is going to say, things that Hamatal might have to say. Okay, so what's our current thinking about HLB in California, in spite of what's happening in Orange County? I'm going to focus now on counties like Ventura, where there's a large active commercial citrus industry where some level of control can be expected. Okay, next slide. So Victor's been working hard to take what we know about the degree day response of ACP to its environment and turn that into a usable predictive model. So if you can click again, this is what the current model interface looks like. Okay, so the model uses an open weather platform that lets us forecast about 14 days ahead, but it means that we can drop a pin anywhere on a map and get really high accuracy interpolated temperature data for that location. And then the current way that we express what is happening with ACP at that point is that we have a daily growth index, which is basically based on hourly temperature response by the insect based on what we know about how it responds to temperature. And that lets us say for each day in the immediate past and then for 10 days in future, what we expect the weather to be like in terms of insect development. And the good news is there's a lot of time during the year here and also elsewhere in California where the temperature is outside the comfortable range for the insect. You can see this is back in April here. And just in the week before we did the forecast, it had been on the cold side if you were an ACP. And we actually expected there was probably some population knockdown purely from cold during that period. You can see the red line dips below zero. So we can now give fairly accurate site-by-site monitoring for what we expect the ACP growth index to be doing. And our intention would be to make a dashboard with several locations for the county, say from Piru down towards the coast up to Ojai. So just something that people can keep their eye on that we'll update on a regular basis that PCAs can use for helping with strategic decision making. So that's coming soon. Next slide, please. If we take each day of the year and calculate the average growth index, we can get some sense of how good / bad the model is at doing that. So here is some data from the most recent MAC project where we had 5 sites. So this is a Ventura conventional lemon site and 2 years of data. And I've done my best to line up the 2 years of consecutive growth indices with the data set. And you can see the dark blue bands early in the year in 2021 correspond underneath to low population catches. Then we hit the kind of the yellow-green area and the population peaks because index is more suitable. It's getting temperatures that it likes. Starts to cool off in the fall. We get the winter drop down between the 2 years, again corresponding to the blue area up above. Unexpected early peak in the spring in 2022 that needs some explaining. But then you can see that that sustained period when ACP were relatively easy to find during the summer of 2022 corresponds to the index being in the favorable zone up above. So just even qualitatively eyeballing the index against the data that were collected in the MAC project, we're pretty confident that it's given us a good overview of how good the environment is if you're an ACP, which gives us some idea of the risk that for infection that we're facing. If you move to the next slide. We can do that historically for lots of places around the world. So this is a whole bunch of different citrus growing areas, including some from California. The red box highlights Ventura. So again, we're going from January 1st to December 31st for 4 different years, looking at the daily suitability for ACP development on that day. And you can see that Ventura is characterized by this cold periods at either end of the year where it's too cool for ACP to be comfortable. There are some areas down in the desert which are below Ventura in each of the plot. You can see there's a big dark patch in the middle of the year in those locations. It's too hot for ACP in Imperial at that time. Oh, I see. Georgios is advancing towards me in the room with something held in his hand. I was a bit nervous there, but it's just a pointer. Okay. If we move to the next slide, so we can be fairly confident about the environment and what influence that has on the suitability for ACP. But there's even more good news. Our colleague Greg McCullum spent a lot of the last part of his career at Fort Pierce setting up an infection process system so that the lab at Fort Pierce would have a never-ending supply of infected plants. And he wanted to do that using ACP because he wanted the plants to become infected in the way that they would in the wild. And so as a good scientist, Greg recorded everything that was happening when he was setting up that infection process. So there's a ton of data at Fort Pierce where Greg matched the amount of CLAS that was in the colonies that he was using to do the infection with the proportion of trees that eventually got infected. And that's a really important piece of information that was collected as a byproduct of him getting this infection process set up. And you know what? And it makes me feel good to say this, okay, because I really don't like HLB or ACP, okay? It's a pretty crappy vector disease, actually. In comparison with some other diseases out there, it's actually not very good at doing what it does. And it makes me feel good to be able to say that, okay? It makes no difference to the world, but it makes me feel good to be able to say that. So if we look at the lower left graph, you can see there are 3 different shadings of bars. And those represent 3 different amounts of CLAS that were in the insects that Greg used to do the infections, okay? Now, he didn't have a lot of control over that, right? But they were able to get sort of not so badly infected insects, moderately infected insects, and really highly infected insects. And then they put them on the little trees that they were infecting and looked to see what happened. And you can see that even with the pretty heavily infected insects, a month after doing the inoculation, the most that they saw was that 60% of the little trees that they were infecting had become infected. And that's under pretty ideal conditions in a screen house for ACP in Florida. So really, really humid, not too hot, not too cold, and still pretty heavily infected insects are not infecting every possible shoot tip that they come across, okay? That's under ideal conditions. We don't have ideal conditions much of the year round for infection here in Ventura. So this represents something that's way worse than we are seeing in California. We didn't know that 6 or 7 years ago, okay? And I'm really grateful to Greg for collecting that data so carefully when he was doing his experiments. So we can take that piece of information and add it to our developing knowledge about this system. And if I can have the next slide. So here's our friend and colleague, Judy Brown from Tucson, who worked with us on both of the MAC projects, testing the samples that were collected. And this graph is looking at the actual CT values from data. Some of the data that are in there are Ventura data. There's also Riverside and San Diego data in there. But going from left to right in that graph, you've got stage 1 and 2 nymphs, then stage 3 nymphs, then stage 4 and 5 nymphs, and then adults. So that's what the different panels are, right? So as we go from left to right across that chart, the insects being tested are getting older. They're going through their life stage. And there's 3 different bars in each, 3 different points in each panel because we had 3 locations, right? We had Ventura, Riverside, San Bernardino, and San Diego. But you can think about the panels as representing the insects getting older. And you can see that as we go from the youngest insects on the left-hand end to the oldest, to the adults on the right-hand end, there's generally a trend. There's a lot of noise, but there's generally a trend for the value to go down. So that's the CT value, or what Judy calls the CQ value on the vertical scale. And it's getting lower as we go from juveniles to adults. And then those red lines going across the plot, those are the data taken from Greg McCollum's experiments showing the different amounts of CLAS that he had in his insects on the same scale. Okay, so to get 60% infection, you have to have a CQ value this low or lower. And you can see we had 1 sample from the insects collected in commercial citrus from Southern California. 1 sample over 2 years was below that upper level that Greg was using in his experiments. The upper red line represents the lowest amount of CLAS that he had in his experiments. And even under ideal conditions in Florida, that was only causing about 20% infection. So there's some evidence here that our insects, certainly when they're young, probably aren't capable of transmission. They couldn't go anywhere and transmit anyway. But even if you took them from those plants and purposefully put them on healthy plants, supposing they survived the transfer, they would be unlikely to be able to infect anything anyway. Okay, so we've got evidence from field data collected right here that our insects here need to get to be adults before they even have enough CLAS in them to do any damage. So we really do have an opportunity, if we can kill them when they're young, to really cut down transmission completely. Okay, and then there's even more good news. So if we can have the next slide. Okay, so here's data collected by our colleague Silvio Lopez from Fundus Citrus in Brazil. And what Silvio's postdoc, Juan, did was look at the relationship between ambient temperature and the translocation of CLAS in the plant in a series of controlled experiments. Okay, so they have these little plants, which we can think of as shoot tips on a bigger tree. They inoculate it in one place, and then over the period of time, they look to see how far the CLAS moves in that little plant by destructively sampling the tissue and testing it to see if they can find the bacterium. Okay, and then on this heat map here, what we're looking at is the temperature in Celsius from 0 to 40, and then the suitability of transmission or transport of the bacterium on the vertical scale. All you need to take away from that chart is that if it's blue, the bacterium's not moving very much, if at all. Okay, if it's red, the bacterium's moving. And so what do you see? That there's a really sharp temperature optimum for the bacterium around 25 degrees Celsius, which is what, middle 70s, 80, 76. So as it gets warmer than 76, the bacterium stops moving. If it gets colder than 76, the bacterium really stops moving in the plant. It sits where it was put into the plant for an extended period of time. Okay, and this, I think, also tells part of the story about why we're not seeing such aggressive spread of the disease in California. Many of our citrus producing areas either spend a lot of their time, if not all day, then at least for part of every day, either too cool or too hot. And the bacterium simply isn't as mobile in the trees here as it would be in a subtropical climate. Now, these are not absolutes, okay? We know we can get infection here. We found 7,000 infected trees in backyards in Southern California. It can happen. It's not a yes, no thing. But the underlying odds are much more tipped in our favor than we thought they were 10 years ago. Okay, so all of that comes to the question then, is an IPM approach safe? And if it is, what's the threshold? And I don't know how many times I've been in different meeting rooms here in Ventura and had Tom or Dave or somebody else say, you know, what's the threshold for ACP? And I'm going to admit here to being a bad PI, okay, because Sandra has been saying from her background in dengue transmission and vector biology, there's a lot of stuff in the vector biology literature I think we should be looking at for ACP. And I've been saying, okay, Sam, well, go ahead and look at it. But she didn't make me sit down and look at it until relatively recently. I should have listened to her. There's a lesson there. Next slide. Okay. Okay. Never mind the equation so much. Okay, it turns out that people who are interested in the study of malaria and dengue and other mosquito transmitted diseases have known for a long time that in those systems, there are definitely transmission thresholds. If you have fewer than M prime insects per host, per human, if you have fewer than that number of infected insects, you don't get transmission. Transmission is not maintained in those systems. And that's really the success of a lot of the vector biology control programs that happen in human vector diseases, is getting the number of vectors lower than that threshold for transmission. So here's the question. Can we do the same thing for ACP? And here's my guess. So you don't need to really understand the equation, just know what the different things are if the algebra hurts your head. So P's the probability of an insect surviving one day. And I'm going to guess that on any individual day, there's a 90% chance an insect's going to survive. Mark might want to argue with me about that. We certainly want to get that number lower if it is 90%. R is the rate at which hosts are removed from the infected state. So either they recover or we find them and take them out of the population. They can recover if the infected leaves fall off before the bacterium has a chance to become systemic. I'm going to say that that's 0.05. A is the proportion of insects feeding on a host each day. I don't know what that number is, but you know they spend most of their time feeding because they won't grow up to be big ACP if they don't feed. So I'm going to say 90% of the insects feed every day. The proportion of feeding events that result in an infection, well, we've seen from the work that Greg did that that's not a huge number. So I'm going to guess it's 10%. The probability that a vector acquiring a pathogen, the vector acquires the pathogen from feeding. So the disease won't really take off unless we get that feedback. Again, we don't know what that number is, but it's probably not huge based on other stuff that we know. So I'm going to choose that as 10% too. This is just for illustration. Okay. E is just E. It's Euler's number. Remember, logarithms, natural logarithms. And then G is just a different way of writing P. Okay. And then the most important thing, or one of the most important things here, is the latent period. In other words, how long does an insect have to be infected before it can become infectious? Well, this is where the life cycle really plays into our favor, because it's the entire period of the juvenile age of the insect. Even if that's not strictly true biologically, even if there are late stage nymphs that could theoretically be infective, they can't go anywhere. Okay, so the latent period is the entire juvenile lifespan of the insect, which I'm going to set here at 20 days as a kind of ballpark figure. So if we plug all those numbers in, if they're true, if that happened to be the truth, then the answer is 5. Okay, so I wished it had been 42. That would have been so good for so many reasons. But it turns out with those numbers, M turns out to be 5. What does that mean? It means that you would need to find 5 infected psyllids per tree across an area on average in order for transmission to be guaranteed to be maintained in that system. Okay. And Tom was telling me after we got over lamenting how badly our two baseball teams are playing at the moment, that he's having trouble finding any ACP at the moment. So even though realistic guesses about what that number might be are low, they're not actually so low as to say, hey, you know what, M is so low that it's effectively zero. I think M probably is not effectively zero in our system. Okay, even somewhere as conducive to ACP, relatively speaking, as Ventura. So there's a realistic chance of being able to build a threshold-based IPM system for this vector disease, even though traditional plant pathology stuff about vectors would tell you that that's a dangerous approach. I'm going to go out on a limb here and say, I think we can do it. I think you can do it. And I want to say thank you to you guys for keeping pushing us to think about this stuff. We wouldn't have got here without the community engagement in this problem here in Ventura. So this is a result that you guys have some ownership in. You drove the agenda. So thank you for keeping pushing us to do this kind of stuff. It really means something to us. Okay, so last slide. The nice thing about the way that this works is that we can say what sorts of things affect those different things that go into that calculation. So the probability that an insect survives, the temperature, obviously, whether there's predation or parasitism, obviously whether there's pesticide use, whether there's food availability. If there's no flush, they can't feed, they're more likely to die. So those are the kinds of things that affect P. So we can go through the list. I'm not going to spell it all out. The nice thing is we can tie all the parameters in the calculation to things that we know about and things that we can measure. Have we done that yet? No, not at all. But this kind of gives us an agenda for where we can go. And Bo and Hamatal and I and others and Mark are in the process of applying for money from more than one place to try and provide the resources so that we can nail some of this stuff down. And give us a really rationally based approach to ACP and HLB management that we believe will work in Mediterranean climates. It wouldn't work in the tropics, but I think it can work here. So here's an optimistic note to end on, I think. So thanks for your attention this morning.
Thank you so much. Jane,
We don't know.
make sure to restate
So Jane's question was if the tree gets locally infected and then the temperature goes into a pattern where the bacterium can't escape from the point of infection, does it stay alive as a local infection that can't spread, or does it die off? And we don't know enough about the basic biology of the bacterium to be able to answer that question. What the tree will do if the recognition system is strong enough, and it's not completely zero, it's not great, but it's not completely, what trees do with everything when they get infected is they compartmentalize, right? So the tree will try and wall off that infection if it recognizes that it's there. And so if those bacteria get trapped in a little patch of the leaf or whatever that's suberized and they can't escape, then the chances are they would just sit there even if they're alive, and that leaf will eventually be shed or trimmed off. So there's probably some of that going on. But bacteria are tricky things. It's hard to know when a bacterium's dead, right? Right, Georgios?
Would you mind using the microphone? I have a feeling it won't be easy to summarize your statement.
Well, thank you, Neil. That was a very nice analysis, and I was looking forward to meet this group. I've heard so many things about you. Georgios Vidalakis, UC Riverside. The key here is the flash. So the bacterium is introduced to the young feather flash, right? So as the leaf grows, compartmentalization is a little bit difficult. A study from Svetlana Foliminova, phytopathology, I think, where she actually went with electron microscopy and saw the bacteria in the introduction site, and as the flash is growing, bacteria that are left behind as the flash matures, they do fall apart. They break down, they die. But in the younger flash, there is bacteria, live bacteria infection. And that's the key, as many of you already know, the game is played in the flash. So that flash that still has some live bacteria, when the next mama or the nymphs that just now became adults, they will lay their eggs and the nymphs will start again the cycle. They have tried in Brazil. It's not therapeutic. Maybe it slows down. It doesn't solve the problem. There is disease that this works, like leprosis, for example, that is mite transmitted and is localized. But with HLB, it hasn't been effective to prune off the branch. The African version, it does work in some cases. They actually don't even bother cut with a blowtorch. They grab the branch. Yeah, they grab the branch. They kill the phloem on that branch. It works, but it's the African version, which unfortunately we do not have. We deal with a difficult system.
Mark?
Mark, will you do me a favor and use the mic? We have 40 people online that would love to hear what you have to say.
Thank you. Neil, I'll reiterate. Great presentation. Thank you. Awesome. OC, very interesting. There's a huge natural experiment going on there. The last few slides that you showed, that interesting parabolic curve with the heat map, does that fit anywhere close to what the temperature profiles would be in OC? And then the second question I have is that transmission equation that you showed, is there enough in there that you could pull out of that to see if those numbers are even approximating what we're seeing in Orange County? I feel like there's a lot of theory and a lot of potential model type data or approaches that could be applied to the system in OC to see whether or not any of that's close to being correct.
Yeah, so that's what Victor's working on right now, is to, having kind of nailed down the insect side of this environmental thing, he's moving on to look at that question of what is the temperature profile in California in different places, tell us about the likely movement of the bacterium. And so it's a work in progress. And then, yes, Mark will be coming to you, we'll be coming to other people who might have data from experiments that would help us get a better idea of what the numbers should be in that threshold equation, so that we can present something that's a bit more robust than Neil's guesses about what the numbers might be.
And one thing, sorry, I forgot to mention, that number that you saw on the colorful tables, the 0.04 for Ventura, right? If I remember well.
Yeah.
Absolutely critical number. In Brazil, of course, with all the caveats that Neil mentioned, tropics, a lot of farms not irrigated in Brazil, constant flushes and so on. However, in Brazil, in commercial blocks, if they can find 1% infection, they abandon the whole block because they know they are at least 25% in real life infection. So either you jump, like you're in a golden stage right now in opportunity.
This might come up later, but I was just curious if anybody's done studies on, say, Riverside and maybe like the Argentinian ant populations or the other insects that are farming those, if maybe that is adding to the situation. Because as far as I know, when they find these situations, they're not treating for the ants either.
Right. And I could talk about that, but I suspect that Mark will make much better informed comments about ant control and its relation to biological control than I could do. So I'm going to, if you don't mind, I'm going to punt that question to Mark to deal with when he comes up to speak.
Also, we're going to do a deep dive on hydrogels and all the work that's being done on Argentinian ant suppression at the Ag Tech Fair on September 10th. So I've banned Yvonne from giving you all of the things so that you have to attend the Ag Tech Fair to get that information.
Under the concept of right time, right place, is there ever a time where in the stage of the facility where it's immune to pesticides? Or in addition, it's more susceptible to heat or cold?
So the insects that have never been exposed to pesticides, there are no life stages that are immune to the effects of pesticides, right? You can kill the insect fairly readily with a wide range of active ingredients, hence the number of products that are named on the UCIPM guidelines for psyllid management. Over time, with repeated use of products, you get the buildup of insecticide resistance like you do in many, many pests, and the Brazilians are, and even the Floridians are now in that kind of world where they have populations that are quite insensitive to some of the more widely used products, and those products are no longer available to them. So that can happen. And then you asked about heat and cold, I think. Yeah. So in general, the adults are more robust than the eggs and the juvenile life stages. And if you look, for example, in what happens in the desert here, the insect pretty much survives over the summer only as adults. And our colleague from Florida, whose name has Lucas Stalinsky, went out and looked in Florida on plants that weren't citrus to see in the hottest months there if adult ACP were found on other plants, even not even relatives. And they did find some adult insects on other plants. Largely, they felt just surviving by drinking, not really feeding in the way that the insect would normally feed. The other life stages aren't strong enough to be able to do that. And in very hot conditions, and you get heat spells here that would qualify for that. Really, the adults are the only life stage that are likely to survive a hot spell under the kinds of conditions we have, even here on the coast. So quite often the insect gets carried from periods that are suitable for reproduction purely by the adults being able to survive over those times.
We've had some heat waves in the past that have taken us well over 110 degrees.
Yep.
Is there a possibility where it could actually wipe out the bug?
Yeah, I think in not across the county as a whole. There'll always be places, even in a heat wave like that, where there are refugees. But I remember being out in the field with Ben after one of the heat waves in the last few years, looking at damage on avocado with him. I was here for another reason, but he said, you've got to come out and see how awful the avocados are looking after the heat wave. You know, you're going to get, you will get localized eradication from really prolonged hot temperatures, but being mobile, the insects generally a few of them will find places to hide. And if a few of those are gravid females, then they'll start egg laying as soon as there's something for them to lay eggs on, as soon as there's any flush available. So the process will kick off. But yeah, you could definitely get localized eradication for sure. Even using the detector dogs when they go down to Yuma and Imperial, they don't find adults in every block that they check, even if they find adults relatively easily in some of the blocks that they check. So you do get, the population becomes very patchy at prolonged high temperature or prolonged cold temperature.
Great. Well, thank you so much, Neil. I think we're going to end it there, but we'll always accept questions that the task force can give over to Neil. And I think he included his contact information in his slide deck too.
Hi, good morning. Thanks for having us here. We're going to do answer a few specific questions that had come up working with the task force for HLB in Ventura. So I'll trade off with Hamatal. And just to quickly address two of the questions that came up, I'm really glad to hear that Neil's team is going to look at the parcel facilities and the shipments that come in. I worked in the county lab in San Diego that saw all of the interceptions that the dog team would find in the parcel facilities and was pretty concerned about everything that they were bringing in. So I'm really glad to hear that that's going to be looked at in a data-driven way. And then for pesticide testing and looking at new products, we are picking up I've been contacted by a lot of different registrants with different products to test. And so we're working on that. I did a brief trial with Frank Byrne before he retired, and we have a lineup of more products to test in California conditions. Can I, no, okay, so next slide. So I'm at UC Riverside with UC Cooperative Extension. I run the Subtropical Fruit IPM Lab. So that's citrus, avocado, dates. We have some other projects starting up in coffee and other specialty crops. So the main pests at the moment are ACP and thrips in citrus and avocados, the fruit fly invasion. We do a lot of sort of field on the ground work, working closely with the local farm advisors. So I'll hand over to Hamatal and then come back.
Next slide. And for those of you who haven't met me yet, my name is Hamatal. I am the entomology advisor here in Ventura County. So my position is to create a research and education program around insect management for all of our regional crops, including citrus and avocado and strawberry, other vegetable and fruit crops as well. So I work on anything from insect ecology to conservation to pesticide resistance monitoring to IPM of local pests. Next slide. So the theme of today's research talks has been, how do we enhance IPM of ACP? And in theory, an IPM approach would have a combination, a suite of methods to control a pest based in monitoring, cultural control, biocontrol, mechanical control, and then at the very top, chemical controls. But in actuality, on the ground, our approach for ACP in Ventura has really been anchored by a combination of monitoring and chemical controls, our area-wide management. And as Neil mentioned, we're kind of at an inflection point right now. We have an opportunity to really revisit what does it mean to develop an IPM approach for ACP. Next slide. Indeed, there's some kind of challenges with our current approach. So UC hasn't updated their pest management guidelines for ACP in over 10 years. We're missing some pieces of the puzzle. Right now, we're not monitoring for things like pesticide resistance. And then there's a lot of questions about our area-wide management and our use of chemical control, particularly winter sprays. We learned from Neil that it's really important to control nymphs because they're the ones that we have to attack. But our winter sprays are focused on killing overwintering adults. So we don't really know, are winter sprays doing anything? And then finally, ACP hasn't really been present this year in high numbers. And we don't know why that is. Is it because we've been really effective at controlling it? Or is it something to do with our regional factors, weather patterns that we have here? Next slide. So Bodil and I, over the next few years, our goals are to specifically address some of these challenges by updating the UC pest management guidelines, developing an ACP resistance monitoring program. We are going to be kind of addressing this question of winter spray treatments, and we have some preliminary results to share today. And then we're going to be talking about how we might enhance our understanding of ACP population dynamics with a data-driven approach called ecoinformatics. Next slide. So our approach for updating the pest management guidelines is to collect all of the different UC researchers who are working on ACP and really focus on tailoring the recommendations to different regions and different cultivars. A lot of these guidelines were developed with just in the Central Valley or with certain regions in mind. We have a lot of biocontrol research that's been accomplished by Mark Hoddle and his lab, and we're thinking about how can we get this information formally out as part of the guidelines. And then a big part of this is really talking to you guys. We're going to be asking you for your feedback on any changes that we might want to make and how that might impact you. All right, next slide. for ACP resistance monitoring. In 2012, Frank Byrne, Beth Caldwell, and a few others collected some baseline populations of ACP and tested them for their response to the top pesticides common. I think it was 12 different pesticide classes. And so far, no one's really gone back and assessed, is ACP still showing the same susceptibility to these pesticides? So Bodil and I are really interested in starting a resistance monitoring program. Basically, you collect adults, you knock them out with carbon dioxide. While they're temporarily knocked out, you apply pesticides to them, and then they come back to, and you wait and see if they die after 24 to 48 hours. Next slide. This is a picture of the microinjector that we use to test ACP for resistance. So this allows you to place little drops of pesticides on their back. Next slide. And this is what, ACP looks like dead after a bioassay. One more slide. So there's some opportunities in this monitoring program to test some pesticides that were not previously tested with the baseline population. And they only looked at adults, but we need to work on some protocols for nymph control. And realistically, it's going to take us a couple of years to get funding for this project and set up the monitoring project. So we just wanted to share kind of like a realistic timeline with you. And I'll hand it off to Bodil for the rest of our update.
Okay, thanks, Hamital. So specifically, a question that had been asked from the task force last, I think, November, was to evaluate the efficacy of the winter spray treatments. And the idea with these treatments, let's see, is that you're knocking down the adults in winter before they lay a bunch of eggs. And so if you're applying a spray in winter, then your spring population is much lower because all of those eggs don't get laid that then turn into nymphs in the as the temperature heats up. Next slide, please. So the way that this had come about, the motivation for winter sprays is this idea that you're killing, kill one adult, you reduce all of those eggs. It's easier to knock the population down when it's at its lowest and you only have to kill the adults. Maybe the beneficials are overwintering outside of the grove, and so there's less harm. But this was based on data from Florida. It's not an IPM approach, it's a calendar spray. Maybe we're spraying when there's literally no ACP in the grove. It's not just that it's below detection levels. So it's a legitimate concerns to address about whether this is effective and an optimal sort of use of our tools. So when this question came up by the task force meeting, I said, well, I don't know without seeing some data what the recommendation would be. So we started to look at how would we design an experiment. Next slide, please. To try and get at this question. And it quickly became pretty complicated to try and work out like a landscape scale paired block design with treatments assigned independently. It becomes kind of a complicated, risky experiment to try and set up like across the whole landscape for a number of years. Next slide, please. And so we sort of quickly realized that instead a better way to get at this question would be using eco-informatics or data mining from scouting records that we already have. So eco-informatics is kind of being used all around the world now in agricultural systems, pooling lots of data from a whole region so we get a much better look at landscape scale drivers of insect populations and potentially more generalizable and applicable results to a particular region. So in this case, we're really lucky. Next slide, please. because we already have a lot of data that's been collected for ACP from this region. So we can mine the scouting data that Neil and Beth and Monique have been collecting here in these 51 groves that were sampled for a lot of years. So we got this data from Sandra and started to look at it. So I'll show you just a first pass, kind of back of the envelope attempt to address this question. The first question, like looking at the data, was do we have some groves that were sprayed and some that weren't? It looks like we do. And we have all of the nymph and adult data that we need. So the graph on the next slide is just a very quick first pass looking at this question. So in paired blocks, so looking at like within a grove, how does the ACP density change from winter to spring, spring being like April to June or whenever your next subsequent spray was. Basically, the trend that we see here is that groves that received a spray in winter saw a bigger decrease in ACP densities in the following months into spring. So here, from this data, there's a suggestion that the winter sprays are decreasing ACP densities into spring. And this is when we look at, this is the change in nymphs. So this is the blue are the groves that didn't get sprayed, and then orange are the ones that did get sprayed in winter. So they saw a bigger drop in the nymphs per flush, the percentage of flush where we found nymphs, and then the adults, number of adults that were found in tap samples. So next slide. So basically, I need to give a lot of caveats here. This is just a first pass at this data set. So the first question we had was, will the data support a full analysis? It looks like we do have sufficient statistical power that we can really address this question properly with this data. But because this is observational data, the study wasn't designed for this question. We need to do much more complex statistical models to rule out what else could cause this trend that we see. So was it that the groves that saw a bigger drop in ACP numbers were the ones that had less ACP to begin with, and that's why they didn't spray? Or was it all one citrus type? How does, is lemons different than oranges? Here we just looked at everything. Where they managed differently, like organic versus conventional, the timing of other sprays, were all of the groves that sprayed in one geographical region, and that's why we see these differences. So very preliminary. Basically what we can say is we'll get back to you with a more clear result before the next winter spray period. But it looks like we can address this question, and it seems like it's something worth pursuing with this data set. Next slide. So just stepping back, in this case, we're really lucky that we have this ACP data that was collected from this funding that Neil and Beth and Monique had for years to kind of get all this data. For other pests, we have the same situation where we really need landscape scale data that it's really hard for researchers to collect on our own. So next slide. We've used this approach in the Central Valley for a lot of different pests. They had the question, are the pest profiles different in mandarins? And we looked at this with a number of different, thousands of grove years of scouting data go in to make these, the graphs. And every pest we looked at, we were able to see differences in mandarins across the Central Valley. Next slide, please. And this was a really effective way to get the IUC IPM guidelines updated specific to mandarins. Next slide, please. So we just got some funding to build out this data set from the Central Valley into the Southern California regions. So it's this SQL database that that's totally anonymized. We have it all of the protocols set up to enter the data. So we're hoping to build this out, especially for citrus thrips, ACP, whatever other scouting data we have that could be useful. And next slide. So if you have, some scouting records that could be helpful to include in this database, you saw the earlier slide, it ends up all getting pulled together as all we reports the means. It's totally anonymized. And our goal here is to be able to look at regional and cultivar specific questions. And this really helps drive our field and lab-based studies. So thank you.
Thank you so much, Dr. Cohen and Dr. Cass. Do we have any questions? I know it's so cool to me to be a part of the task force and then see our comments turned into research projects. So thank you so much. And I really look forward to hearing the results as they come out.
Yeah,
Thank
we'll
you.
report back before next winter. Okay, thanks.
Okay, that's it. Thank you. So I was asked to come up and give a presentation on how we may be able to enhance natural enemies in citrus to go after the nymphs that Neil has told us are probably the most important life stage that we can knock out of the orchard. So we've done a lot of work on this over the last, I can't believe we started this in 2010 and we're still going. So it's coming on 14 years now. So one of the ways we've been looking at trying to amplify biological control in citrus orchards is through this idea of conservation biological control, particularly through the use of cover crops. So conservation biological control is the idea that you can conserve, enhance, and promote natural enemies that are already existing in your orchards. You don't have to buy them and release them. We have very effective natural enemies that are naturally occurring in citrus, at least where we are in the Riverside, San Bernardino area. The idea is, can we, exploit those free control services to get an even bigger impact from them? And one way we can do that is through these flowering cover crops to provide these natural enemies like these syrphid flies, the nectar that they need for energy to fly from tree to tree, and the pollen that the females need, that's the protein source to mature their eggs. Okay, next slide, please. So this is a three-pronged story. Hit the, there we go. And again, please, we've been dealing with Asian citrus psyllid. We're not going to be talking about this natural enemy that we brought in from Pakistan. This is Tamarixia radiata, the parasitoid that goes after ACP nymphs. We are going to be talking about the ants, because it was the ant work that we did that made us realize that these natural enemies, the syrphid fly larvae, are the key predator that we have that are naturally existing in citrus orchards that provide an immense amount of free control services for growers. Next, please. So, how did we stumble upon this? Well, when we were running the studies to evaluate the efficacy of that parasitoid that we brought back from Pakistan, Tamarixia, we were putting out these small citrus trees that had ACP nymphs on them. A lot of them were disappearing. We didn't know, where are they going? What's killing them? When they were parasitized, we could see a hole in the nymph where the parasitoid had emerged, but heaps of them were disappearing. So what we did was we built these tiny little video cameras that we put in front of these infected citrus trees that had ACP on them, and we filmed them 24 hours a day. They had special infrared LEDs so we could see what was happening over about a 5 to 7 day period, swap them out and keep going until all those nymphs had either been killed or they had developed into adults. Next, please. So we had 19,200 hours of video data, digital video data to go through. A massive amount. We had screens set up, a lot of undergrads, high speed, going through all this stuff, but the data were very revealing. We captured 647 unambiguous kill events. Next slide, please. The majority of them, 60%, were from these syrphid fly larvae that we had never seen in the orchards, despite being out there all the time. They're nocturnal. They were coming out and eating our ACP nymphs when we weren't around to see what was going on, but that infrared videography was picking it up. Next, please. About 30% of the kills were from our parasitoid. It's very lazy. It's only active in the orchards between 10 in the morning and 1 o'clock in the afternoon, and then it disappears. I don't know where it goes or what it does for the rest of the day. Next, please. And then very few events from naturally occurring lacewing larvae, which we thought would have been important, but apparently they are not. Syrphid fly larvae by far dominate in the predator guilds that are associated with ACP. Next, please. 60% of the predation events were occurring at night. That's why we never saw them, because we were only out there in the mornings, come back to the lab, load up all the data, then get on with the rest of the work for the day. The ants were always present on those ACP cohorts. They were protecting them from natural enemies, and they were harvesting that white sugary stuff that comes out of the butt ends of the nymphs. That's the honeydew. These ants are sugar feeding specialists. They will harvest that dry honeydew, those honeydew ribbons, and return them to the nest to feed the brood and the queen. Next, please. And here you can see ants tending the ACP nymphs. You can see the tails of those honeydews have been cut right down to almost nothing. When the ants aren't absent, they form these long lines, but then the ants come in, chew them up, and then take them back to the nest. Next, please. This is why we don't like the ants. They attack our natural enemies. Tamarixia, for example, is extremely vulnerable to ant activity, and it gets taken out. So you've heard about the hydrogels. Our lab has been instrumental in developing those and field testing them, and they are very effective at knocking back Argentine ants. Next, please. Okay. Before we got to the hydrogels, we started using these liquid bait stations to kill ants in citrus orchards. And I'm not going to bore you with the details, but we would put out those stations. They had a 25% sugar solution in and a very low level of thiamethoxam, a vanishingly small amount, 0.0001%. We set this up across multiple orchards. Some plots had liquid bait stations, others didn't. We'd go out to those citrus trees, count the number of ACP and other pests on those trees. We're going to jump over all of that now to get to this slide. Just hit the button. So the bait stations were very effective at knocking down ants, shown here in blue. And then when we didn't control the ants, the numbers stayed very high. Next, please. 20% fold difference below the action threshold. Next one, please. This is what's really important. Before the ant control happened, the levels of sap-sucking pests, scales, psyllids, aphids, and other things were pretty much similar between the treated and untreated plots. Then we put out the ant control. Next, please. 97% reduction of sap feeders on the twigs. Next, please. Huge reduction of sap feeding pests, mainly ACP on the flush growth, 84% reduction. Next, please. And then pests like citrus mealybug and even red scale on the fruit declined by 97% once the ants were taken out of the system. Okay, so we were collecting all these data on the natural enemies, the populations of ACP, and this is what we found. Next, please. So how do we explain those massive declines? Next. Well, it was parasitism and natural enemies. That was the only control going on in these orchards. These were low IPM orchards in Redlands, and they weren't spraying. So within 6 weeks of controlling those ants, natural enemy numbers surged by a 9-fold increase compared to the pots where the ants were, a massive increase. And then they all disappeared. There was nothing left for them to eat. The irony of the study was we ended up finding more natural enemies in the ant plots because there was still some food there for them to feed on. And in the ant plots that had been wiped out, there was nothing for them to feed on. So we had a really hard time finding natural enemies because as soon as the little populations came back, the natural enemies were on them, just kept knocking them down. There were no ants to interfere with those natural enemies. Next, please. They never recovered in the ant-treated plots. As long as we kept the ant treatments up, the pests never came back for over a year. Next. Okay, so we mined those data. From the videography, we had seen that syrphid flies were important. But now we actually had some population level data which showed us clearly that those syrphids were tightly synchronized with the presence of ACP nymphs on citrus flush. You can see here in blue the numbers of ACP nymphs that we were counting on those trees going up and down. And then you can see how the syrphid fly larvae were tracking those ACP populations. The adult flies, the females, are very good at finding those colonies on citrus. They will come in, they lay a lot of eggs. Those eggs hatch into those little maggots that crawl around, and they basically eat every ACP nymph that they can get their mouth parts onto. Next, please. And they're not bothered by the ants. This is the only natural enemy that we have seen that will fight back when the ants come to interfere with them, when the syrphids are trying to feed on those ACP nymphs. Next, please. Okay, so those bait stations, highly impractical for use in citrus orchards. If you're going to realize the impacts of ant control, we need a better strategy for delivering that poison. So just hit the button, please. They're expensive to buy, about 20 bucks each. Maybe you need more than 20 per acre. It's just cost prohibitive. You need to collect them every month, clean them out, recharge them, put them back in the orchards again. Bait quality deteriorates, it ferments in the hot weather. Evaporation causes the sugar content to become too high and the ants won't feed on it. It gets sticky. Ants get stuck around those bait stations. It deters other ants from coming to feed on the liquid. Okay. Can we design a better bait delivery system? Well, yes, you've seen these talks. We came up with these biodegradable hydrogels. They last in the orchard for maybe 2 or 3 days and they just dissolve into the soil. They're made out of algae, same stuff that's in your ice cream. You can buy it all online. There's tons of YouTube videos with little kids making things like this. And you can swell them up by putting that sugar water, dropping them into the sugar water solution, and the ants recruit to them rapidly. So, why aren't we using this stuff? So here's the irony of this whole situation. DPR paid $1 million across 3 labs to develop and field test these things, which we've demonstrated work great, high industry demand for them. The biggest impediment to deploying this DPR-sponsored research is the Department of Pesticide Regulations. Their own regulations prevent us moving this from the developmental stage to you guys to actually use in the field. Despite their granting program investing about $1 million in the development of this technology. David Haviland is still fighting to try and drive this through. He's the UC Cooperative Extension expert based out of Bakersfield. The rest of us have dropped out, but David is hanging on by the whatever fingernails he has left, trying to get DPR to roll and allow this stuff to move into the field. But we are stuck right now. Next, please. Okay, this is what our citrus orchards typically look like. Extreme levels of weed control. If you are a natural enemy surviving in this ecosystem, it's very tough for you if you need nectar and pollen. It's just not readily available. Next, please. So Nick Irvin in my lab spent a lot of time evaluating different flowers that we could possibly plant deliberately into citrus orchards that could act as food for these natural enemies, especially syrphids, since we've identified them as being important natural enemies. We looked at California poppy, we looked at Phacelia, those are native plants. We looked at alyssum, which we're going to talk about here, the white flowered one. And we also looked at buckwheat, not the native Californian buckwheat, but a commercially available one. That's, the seeds are harvested and used for making flour and other stuff as well. Despite these plants being put in this barren landscape at Ag Ops, syrphid flies would come to them. From where, I got no idea. But they would come in large numbers and they really found alyssum to be a very highly attractive food source for them. Next slide, please. So to summarize, next, please. So to summarize this, a few would go to California poppy, almost nothing would go to Phacelia. These are California drought-tolerant plants. Buckwheat was pretty good recruitment, but boy, did the flies love the alyssum. So based on those trials, we decided to go with alyssum to test in commercial citrus orchards in the Redlands and Riverside area to see how well this would do for attracting the free natural enemies that are already there. Next, please. So we did some small experiments first in unsprayed orchards where we put out alyssum in plots. We had control plots set up without the alyssum. We did our same system. We put out little plants infested with ACP, and we just wanted to see what happened to them when the flowers were there, compare them to plots that lacked flowers. Next, please. Go out every other day, count the survivors, count the numbers of flies. Natural enemies would come in readily. They would start laying eggs. This is Allegrapta obliqua, laying her eggs in these ACP colonies. And look at these little maggots attacking fifth instar ACP nymphs. They're extremely ballsy. They take on prey items that are much bigger than themselves, and they will kill and feed on. It's amazing. Next, please. Okay, next. So what we found was when the alyssum was around, we would end up with 3.5 times more eggs on those ACP patches in comparison to the control plots. We'd have more hoverfly larvae on those plots, and obviously they ate more ACP, so the numbers of ACP survivorship was significantly reduced. Next, please. Okay, so part of this work was, well, you know, what hoverflies are out there? We found at least 6 species, but only one was always associated with ACP colonies. This is Allegrapta obliqua. We even have a hoverfly, which I didn't know about. I thought they were all predatory, but there's even a species we would find in the orchards that's a specialized detritivore. So this was interesting. I don't really know what it does in the orchards. So in the lab, we were curious as well, okay, well, you know, how many ACP nymphs can a larva eat? On average, it needs about 421 to complete its development. So if it finds an ACP colony, it will kill every single nymph in that colony, and it will work its way up and down the green stems, feeding on everything. Next, please. So can we use alyssum in citrus orchards? And that's what we've been looking at. Yes, you can. It's not under any sort of, as far as I'm aware, any DPR regulations. Okay, so we've run some field experiments. You know, what effect would alyssum have on pest numbers in commercial citrus orchards? So we put out some plots. Some of them were mixed alyssum and buckwheat, and then we had control plots. We ran these across replicated sites in Redlands, 3 orchards, Hemet, we had 6 sites. Okay, next, please. So we would only plant these seeds in these 6-meter rows using the irrigation line. So we didn't have to set up any specialized irrigation. We'd done this work before. We would actually try and plant them between the rows of citrus trees, but that was very difficult. They needed supplemental irrigation, which was often destroyed by farm workers or animals. So we would drill in the buckwheat at about 85 grams per plot, alyssum much less, 1.8 grams. The seeds are much smaller. Use the existing irrigation levels. Buckwheat would flower within about 30 days. Alyssum would flower very quickly. And we would reseed every 4 to 5 weeks. We just repeated that once. But with alyssum, it's a beautiful system. Once it's in, it will self-seed, and it just keeps going on its own as long as that irrigation water comes in. Next, please. Okay, so yes, big impact at the Redlands sites where we had alyssum. We had a lot more flies coming into those sites compared to the control sites. Where we did this work at Hemet, we saw no difference. Why was that? Next, please. The Hemet sites, the soil was different. We had issues with drainage and flooding. But more importantly, we had big problems with deer and rabbits at those sites coming in and feeding on those plants. And we tried rabbit scram and all sorts of things to keep them out, but we weren't able to keep them out. So those big herbivores would come in and just mow down our cover crops. But at Redlands, we didn't have those problems, and it performed the way we had expected it to. Next, please. Okay, so here's a flowering pattern for alyssum, planted in the end of February. It takes off and then keeps flowering right through till October, a little bit into November. Those flowering periods synchronize really nicely with when you expect to see ACP on the flush in those orchards. So if you get the flowers out, the hoverflies come, it synchronizes very tightly when you're going to see the highest levels of nymphs on that citrus flush. Next, please. Spring and fall. Okay, so even though we had finished these experiments, we've been back to our sites and the grower's quite happy with alyssum self-seeding and just keeps running down the irrigation lines. It requires no more maintenance now. That system is done. It's a low-lying plant, so it doesn't interfere with any machinery when you try to run it through the orchards. Next, please. Right, this was an interesting problem. At one of the sites, we couldn't get the seeds to germinate. Then we tried transplanting alyssum that we grew ourselves and it still wouldn't grow. So then we brought the soil back to the lab and we ran some paired experiments, and we think simazine had been used so often in the soil that the residue there was just killing off the seeds, because when we had the control soil, which was just basically fresh potting mix, we had no issue with seed germination. So you might need to consider the history of herbicide use in those orchards if this is something you're going to be thinking about. Next, please. Okay, I put this slide in especially for Neil, because I was hoping he was going to be here today and not on Zoom. Okay, just run through it, please. Our natural enemies have killed more ACP than any of the other management programs in Southern California. They're in urban citrus, they're in commercial citrus, they're working 7 days a week, 24 hours a day, 365 days of the year. So our impact, our focus now is, can we make this system even better? And that's why we were doing the ant work with the gels, and that is why we have focused on using these cover crops to try and get as much value as we can out of these free biological control agents that are in your orchards already. Next, please. Okay, so I'd like to summarize all of this in a video that we made with KQED. Yep.
What hovers like a tiny helicopter and flies backwards? Has the flash wasp, the huge eyes of a fly, and spawns murderous maggots? Meet the hoverflies, also known as flower flies or syrphids. There are 6,000 species, each with its own style. Bold stripes or plump fuzzy bodies make them look like wasps or bees, but it's just a ruse. This protective disguise tricks predators into thinking they might get a face full of stinger if they try to eat the hoverflies. This bluff is called Batesian mimicry. This one with the intricate pattern on her back is an oblique streaktail. Right now, she's on a mission in this Southern California flower patch, fueling up on the pollen that will help her grow her eggs. She loves this fragrant alyssum and pollinates it as she darts from bloom to bloom. See how precisely she lands? Her wrap-around eyes catch the faintest motion, just in time for her to escape this hungry crab spider. After filling up on pollen, she uses her stubby but powerful antennae to smell for the perfect spot for her eggs, an orange tree under attack by these yellow insects with curly Q poop. Asian citrus psyllids. The hoverfly lays her eggs next to them. When maggots hatch out of the eggs, they'll have plenty of those psyllids nearby to eat. Orange growers despise Asian citrus psyllids, which spread a destructive bacterium. Instead of these juicy beauties, trees suffering from citrus greening make green, bitter fruit and eventually die. So scientist Nick Irvin at the University of California, Riverside has planted alyssum in orange groves to attract oblique streaktails. Their maggots hunt for psyllids on the orange trees. But the psyllids have a security detail: Argentine ants. They feed on the psyllid's poop. In exchange, the ants try to keep the maggots away. But this big one has the upper hand. It digs its mouthparts in and injects some venom. It even sucks out a little taste to see if it might want to eat the ant. Nope, it's really after the psyllids. Each maggot will devour more than 400 in the week before it turns into a pupa. And that gluttony means more oranges for you and me.
Okay, so we still have a lot to do on this. So there's critical questions, right? Where do you put the alyssum in your orchards? You know, work out of Florida suggests ACP mainly inhabits the margins of orchards. I don't know if that's true in California. Is there any data on that? I haven't seen it. The other thing, it is? Oh, the data's there, but it needs to be looked at. Mm-hmm.
Sorry, it depends. So the same data set that Bo was talking about, if when we looked early on when the data were collected, there seemed to be two different groups of blocks in the data set. There are some where if you have low populations on the margins, there's none in the middle. The middle transects had never had any ACP on, but there was a smaller number of blocks where even if the population at the margin was low, we could still find them in the center transect, and we didn't go back to pick out whether it's just down to size, for example, or not. But that's another question that could be answered from that data set, I hope.
Yeah, that would be really useful because that would help us decide how do we deploy the alyssum through the orchards. Would it just be around the margins? Do you put it down just one central row? Do you have a stepping stone pattern, or maybe you just throw seeds out around, you know, as you're going through your orchard and you have a patch there and a patch there, and that's sufficient. The other thing for you guys up here is that I don't know of any surveys that have been done for syrphid flies to see what species you have here and whether or not Autograpta obliqua is actually present here. And we would have to do something similar for the growers up in the valley as well, because there is some evidence to suggest that these hoverflies do have localized regional distribution. So we'd have to get that figured out as well. All right. Yeah, let's get those sorted out. That would be really helpful. All right, yeah, Dave.
Have you seen any predation on ACP eggs?
So have we seen predation? We haven't specifically looked for that, no. Okay. But it is possible, I think, phytoceid mites may feed on them, but we haven't looked at that specifically.
You know, when I'm sampling for the ACP eggs, and sometimes you see things that are kind of obviously hatched eggs,
yeah,
but
sure.
other times maybe not so much. And I have definitely seen desiccation with hot winds of ACP eggs.
Yeah. Yeah, so I don't know about specifics on egg predation. Yes.
Yeah, one of the problems we have is we are mandated to spray or the Asian facility.
Right.
How do these flies tolerate that?
Yeah, we don't know. And like I mentioned before, I don't know where they go. But when you put the flowers in, they show up. So they're coming from somewhere. And we did look at some of the chaparral areas around some of these orchards, but those surveys were kind of inconclusive. Amatel.
There's actually an online comment that goes along well with that, if you don't mind, if I incorporate that, and then Hamatal can respond, and probably Neil and you will all have responses. So one of our online participants is noting their opinion that there's a gross misapplication of resources. The packing houses and growers are forced to spray everywhere, and then there's no control, and they need to focus on the urban areas where all of the ACP and HLB has been, or sorry, the HLB has been found, and forego area-wide spraying in favor of more investment in these host plants and other control areas or controls in nearby urban areas, and promoting the vegetation hosts that you talked about. So anybody have any thoughts?
Go on, Jay.
Is hoverfly and alyssum an alternative to area-wide management in your view?
Well, is it an alternative to area-wide management? Boy, that's a loaded question. I think what we've demonstrated is those flies are extremely effective at driving down ACP at negligible cost and at no risk to anything else in your orchards. And in fact, they may even be eating other things in addition to ACP in your orchards as well. But that gets back to some of the points that Neil has raised is, what is the minimum tolerable threshold of psyllids? And a lot of it's going to be driven by, are the bacteria, is C-class actually present in the orchards or in the surrounding areas? I mean, these are things that are going to affect the transmission and rate of disease development.
We have Hamitol and then Jane.
Syrphid flies are also probably our primary pollinator of avocado in our county. And so I wouldn't be surprised if avocado is acting as a supplemental nectar resource for them. And we see avocado adjacent to our lemon orchards, really interspersed. So it'd be really interesting to look at that, I think, in the future.
Right. Yeah.
And I was just thinking that this is also a fantastic thing to promote in Orange County and to promote in backyards and to have some serious outreach to the general public because it makes your yard pretty and, get people planting it in their backyards.
Yeah, so I agree with you on that. And I think building ant control into the outreach, people hate the ant. It's in your house all the time. So encourage people to control the ants inside and outside. I mean, that would be really helpful.
That was going to be my point too. And also that homeowners have more resources for ant suppression than we do in our orchards. So if they could use their tools, that would help.
Yeah, you definitely need the homeowners to do this themselves. I mean, the collective us can't go in and start throwing gels in there and then putting pots of alyssum all over the place and say, you got to look after this and, make sure you do a good job. It's the same one. You're not going to miss anything.
If it's not worth saying in the microphone, I don't know if it's worth. So use the mic, please. So a couple of questions while the mic gets passed. Should you plant alyssum in February, and is it a native plant?
Right. So it's not native, but it's native to the Mediterranean areas. That's why it does so well in our climate here. It is a crucifer. So if you have Bagrata bug concerns, it may attract Bagrata bug, but Bagrata bug, at least as far as I'm aware, it doesn't seem to be as big a problem as it used to be, 6, 7, 8 years ago. So that's just one thing to keep in mind when you have alyssum in your, and it will spread. So if you have a low tolerance for creep, then this may not be the cover crop for you, but if you don't care and you want something that's low maintenance, it will just look after itself, this is probably the plant that you should consider.
Margie?
People mentioned it was a mandated spray program, mandatory. It is not mandatory. They cannot penalize you for not spraying. So I think this alternative ought to be more available to other growers instead of constantly pushing the spraying. And if you present an alternative, other growers might adapt that. But this county has been so, dedicated to a spray program for so many years, it's going to be hard to transition people off of that. But we need to make that more of an alternative in this county to farm a little bit more in an true IPM way. what they're doing now is not even close to IPM.
Right.
Okay. So, well, like I said, good afternoon, everyone. My name is Ivan Milosavljevic. I am an IPM entomologist with the Citrus Research Board. I will give a brief overview of what I have done so far. I'm not new to this area in the citrus, but I'm new to an industry position. But before that, I would like to thank Maureen and the Ventura County and the ACP-HLB task force for giving me a chance to speak to you today and give some of the updates that I have on the craft program and other programs that I'm running. So, like I said, I'm not new to this IPM issue. I have been working in a wide array of crops previously. My background really starts in Serbia, where I'm originally from, where I worked in pears, in apples, and managing the different psyllids and aphids. I have started my position in the US in 2012 in Washington State, where I got my PhD and doctorate actually from, working on wireworms, which are pretty much the soil pests that are damaging early seedlings early in the season, and like the below ground portions of these field crops such as wheat, barley, oats, canola, etc., etc. And they're causing the irreversible damage to these small crops. So what I have been doing is developing the IPM recommendations for different species that they are dealing with in Washington, Oregon, and Idaho. After that, after I received my PhD in 2015, I worked briefly as a postdoc as well until 2016. That's where when I joined actually Mark's lab and started working for Mark. So I have been working for Mark from 2016 till the last July, when I actually officially started with the industry and the Citrus Research Board. I worked in different crops in different environments, both urban and agricultural settings, as you can tell. I have, to a very small extent, helped Mark with some of the analysis for the avocado pests, such as the avocado lace bug and avocado seed weevil, and worked briefly in quarantine, help out pretty much with the trials that he was running. I have worked to the most extent in citrus, but also I have worked in date palms and the Canary Island palms that you can see in the top right corner in San Diego area, where the palm weevils are a big issue. So we have been developing some IPM recommendations and pretty cool research updates and tools for the homeowners and for the growers in the Coachella Valley, if this pest gets established over there, which was the primary concern. But also there is a big concern in the urban areas with the date palms, where we are trying to eradicate this pest or slow it down, not eradicate. But in citrus, I have worked with many pests. Mark has mentioned Argentine ants. I have been a part of that program, as well as the citrus mealybug, the ACP to the most extent. I worked with Tamarixia and therefore inserted in urban areas in the releases with the state. So a wide range of pests that I have been working on in his lab for over 7 years, until I recently joined, well, not recently, a year ago, Citrus Research Board to work on to the most extent in citrus and on a much broader scale of a production and on the pest range that I have to deal with. Okay, so the next slide. I'm still developing my position since it's a new position and I'm new to the industry. Basically, I have different roles in this position. On the left side, you can see that I have a supervisory role. I'm overseeing different grants that come from the UC system and other researchers that get the money from the Citrus Research Board in the industry to work on different pests of concern, such as, for example, the citrus strips and the earwigs that you can see. I'm trying to oversee these grants and basically make my recommendations on how to improve these programs. I have also been involved in the lemon pitting issue, and we're trying to resolve this, whether this is a pest-related issue or not. So those kind of are my primary projects that I have currently at the moment to supervise. But I'm writing grants and receiving grants to work on different research-based issues and research-based questions that we as an industry or that the Citrus Research Board and growers are requesting me to do. One of them is craft. I have been appointed as the PI and the contact person for California Craft Program, which is dealing with the ACP management. I have also written and received different grants on ants. I'm still working with David Haviland on the ant issue and the hydrogels. We're still tweaking around different products and different rates on a commercial scale, as well as on the sugar. inside the gels. I have been asked to slow down by Maureen and not to talk a lot about the ants, since I will be covering this topic at the upcoming Agri Fair in September. So please, if you can attend, please attend. I'll have more details about this program then. And recently we have received some money to investigate the commercial releases of Tamarixia, which hasn't been done before. So with that in mind, I'll focus the majority of my talk in the first part on the craft program, since this is really ongoing and requires a lot of my attention at the moment. This is a problem that we are dealing with. I'm not going to spend too much time on this slide, but I like to start my presentation with this slide. Basically, on the left side in the top photo, you can see the citrus industry and the growers, you guys and us, that we are dealing all with this pest issue that is on the right side of this banner, which is the Asian citrus psyllid. We have a pretty unique situation in California compared to other areas where it is being mostly established in urban areas, and a lot of fight has been going in urban areas to slow down the spread of this pest as well as the spread of the disease into commercial production areas. And it has been very successful in urban areas. I'll show that on the next slide as well, and previous research has found. But we are still seeing some, to a smaller scale, numbers of ACP in commercial areas, and that gets me to a craft program that I will be explaining in a few slides. Okay, so you have seen this number, I believe Neil has presented, but this slide is just to tell you that we have a pretty good IPM program, I would say, in place in urban areas. So a program has been developed since 2009, and really we have the quarantine restriction, removal of trees, infected trees, spray around these areas and within the quarantine boundaries. We have the biocontrol program that has been very effective with the releases of Tamarixia, and everything that the whole fight is going on in these urban areas to prevent this pest complex from spreading further into commercial areas. However, what we are really lacking is the IPM program in commercial areas. As everybody has mentioned, that we have these border sprays, area-wide treatments, and a lot of focus has been on the development of these sprays so that we can knock them out immediately, and not a lot of research has been going towards the development and implication of these different tactics that we have to fight off this problem in commercial settings. So when I was appointed as a PI of the craft program, and as someone that has a very extensive background in the IPM and field level IPM, I have seen this as an opportunity to practice IPM in commercial settings. And really, the USDA has started this multi-state program in 2013. Florida has one program, Texas has one program, and we have our own program. And they're all different in what is being done against to be tailored to a specific situation we're facing. So in 2021, we have started with our program, and our program focuses on the assessment of additional mitigations, or basically on vector control. So with that in mind, this is an array of treatments that we have. And we are really not asking growers when they apply to change anything what they're doing. So basically the grower will apply with the acreage that they have in mind, the blocks. It will provide the blocks, and then they will provide the blocks, sorry. And then they can select a variety of these different treatments, one or more, that they can apply as an additional mitigation to their blocks. And for us is to provide the numbers on the ACP and everything else, and to confirm the best practices out of this, of what really works and what doesn't work in a given situation. And in the final end, the growers are compensated each year for being a part of a program for all the acreage, and on top of that, for everything that they are implementing in these blocks. So like I said, on the left portion of this red line, we have preventative mitigations, and these mitigations are based on the UCIPM guidelines. On the left side, the first one on the top is the barrier mesh fencing that you can apply. Then you have on the lower left portion is the windbreaks, like a living large growing trees that you can apply, and both of those are focused on to prevent or stop the ingress of ACP from highways, freeways, wherever the material is being moved into these orchards that are close by. And the third part of this program, or the third mitigation that we are offering, is the trap crops. So I know it's very hard to find a trap crop, such as, for example, the curry leaf plant, that it's more attractive to the ACP but doesn't host the HLB. But there are still different parts of a program where we can accommodate different perspectives and different interests from the growers. So this is not a fixed what we can offer. There is really a lot of room within this program to practice other mitigations, like cover crops that Mark has mentioned, as, for example, a biocontrol option. But to focus on the preventative mitigations, they're being applied once in the lifetime, or when they join the program, and the growers get compensated for that one-time application and establishment of these new either trap crops or mesh fencing or windbreaks. On the right side of the program, we have a threshold-based mitigation, as we call them. We have a border sprays, and these are, again, the additional border sprays that you can apply to treat for the ACP, or the kaolin clay to just to prevent its establishment and inside the orchard as a repellent, right? So they're actually the border sprays, but we also have an option for a grower to select the biological control as a whole grow treatment, for example, or the end control as a whole grow treatment. So they can be applied. When you apply for those, the growers get compensated each time they apply this space per need for the ACP treatment. So you get compensated continuously for these mitigations. And like I said, cover crops can fit within the biocontrol. We can refine the scope of work and present this. So there is a lot of room to practice the research and the implementation of these different management options within this program. It's pretty dynamic, and we can offer this to USDA that is supporting this program, and we can really work around this and try to identify the best practices possible for you guys. And like I said, whatever you feel that you can apply within this program, please let us know, and I'll be happy to work with you on this. I really want to get a better perspective on the IPM, what works, what doesn't work when the populations are really low, and we can treat them now before they explode, right? Okay, so the next slide. So this is how the program started in 2023. We had a delay in start. So we just finished the cycle 1 this year. We're going into a cycle 2, but we just started with basically 1,800 acres. A lot of it, it's in the Riverside County, as you can tell, in the desert area. And we have several grows here in Ventura County as well. When I started the program, the biggest issue for me was that you can tell on the lower, let's say a chart, white chart, that a lot of program participant has opted for additional border sprays, which really got me into thinking, hey, I need to fix this. I need to level up these treatments somehow. So we do have some very exciting news, because when we started the cycle 2, the Imperial Pest Control District expressed interest in joining the program. And being a pest control district, they can really apply whatever we advise them to, and whatever we feel we can do to improve the program. And with that in mind, we are adding a 4,000 acre more to this program in the desert area in Imperial County. And all of these treatments will be leveled up and efficiently compared. So this is something that I have improved based on the cycle 1. We are moving into cycle 2, and we have been received the funding for cycle 3. So what I'm hoping more to see in cycle 3, hopefully growers from your region to apply for our program, as I have been telling you, we can really accommodate whatever you feel it's working in your region, like a biocontrol, the kaolin clay. I don't know, it's not working, but maybe, but whatever you feel you're applying, the biocontrol, the end control, we can do this and accommodate into this program and evaluate those treatments. What we are offering to our growers is basically, we have our field technician, they go and they field scout trees within these blocks that participate in the program. They collect a lot of tap and visual samples from these blocks, as well as we have sticky traps that we're placing every 2 weeks. So grower would get a finalized report every 2 weeks on the ACP counts based on the tap and visual sampling, as well as on the trap data that we're collecting from these grows. So it will be 2 weeks from April to December, and then we slow a little bit down over winter, and we get the January to March data monthly. We also select a subset of field sites to determine the canine inspections. So we basically select the sites that have issues with the ACP, low and higher infestations, and we sort of send the dogs to evaluate these different blocks and compare our evaluation and trap samples to a dog inspections and canine detections. And the growers get the canine inspections within their field. They get to see them at work and get a more thorough data for their grows. What else we are offering to participants is that we have subcontracted with the aerobotics to conduct the, we do these aerial flights with drones once per year. And the grows get a pretty cool data on the health performance of their grows every year, so annually, on how well their grows each block is functioning within that year. So they're being done continuously and consistently year after year, and at the same period, at the same time as it was done in those blocks before. What I have been implementing in this program, and I think it's very important, is like this outreach that I'm doing, is that we are, I like to speak to growers face to face and get what they feel about this program, what else we can do about the program to improve it. And we're also collecting a lot of data on the grow management, for example, what else they are doing with irrigation, how often is the irrigation schedule of the PURs, the weed management data, the trimming and pruning timing, et cetera, the other pests that they are dealing with. And we are, I'm offering them biannual meetings and conducting Zooms with all the grower participants within the program. So it has been pretty dynamic, and I think this has improved the program, and growers like it so far. Okay, so with that, we also have a web page, and the applications can be submitted. I have provided here a QR code where you can go. You can please scan it. Did my best for the first year in cycle 2 actually to improve the web page wording that we have on there. I have also constructed a program requirements file that is pretty extensive and guides you through application and what we are expecting from the participants in our programs, what we are offering to our participants. So everything is now on the web page, and I will keep my best to actually make it more dynamic with the photos and whatever we can offer to the growers, so that you guys can see it and see what the program is all about. With that in mind, you can always contact me through an email or a phone number for a phone call. My email is below here, and my phone number as well is provided. Like I said, I'm the PI for the program, but we also have our program manager that manages a lot of this. And kudos to Ariana, which she's doing a lot of groundwork for contacting and being in constant contact with the growers. We are really offering this. We're trying to improve the program and be as much as dynamic as we can, and get hands-on with the growers and approach them. Whatever you approach us, the questions, we'll be happy to answer them quickly. So we really want to see this as a dynamic program, and that's some kind of a previous programs that were not working for you guys, and you had problems with in terms of not being responsive or not being efficient enough. So with that in mind, I'm going to end the craft, and really, I would like to see more growers from your region apply and work with you on different mitigations, and maybe we can work something out. And I would really like to see that. But what I have here in, like Maureen asked me to provide a couple of teasers, I guess. Well, just one, the ends. This is another one, it's on me. But I will be talking a lot about these in the future. This is something that I have done in Mark's lab and in collaboration with the state and David Morgan, who is in charge of releases of Tamarixia. So we have looked at the data of Tamarixia releases in urban areas. And as you can tell, we had 30 different locations, 10 locations from the coastal areas, 10 from the intermediate, and 10 from the desert sites. So we had 10 desert sites. At all of those locations, Tamarixia was providing a very efficient density-dependent control of ACP. ACP is being presented here in black lines, and then in green lines, it's the parasitism that actually lagged a month, which is great. This is a holy grail of biocontrol that shows that biocontrol was very important component of the releases in urban areas. And this is a living proof that it has worked in urban areas. It has been complementary, and it is something that we should practice in the future. Now, what hasn't been explored is really, and there was a question in the Q&A about Temrixia releases in commercial settings. It is something that it will be really challenging based on all the ACP sprays and everything. But we are, and this is a grant that me, myself, and Raju Pandey, who is also a CRB affiliated entomologist, have been developing previously. He has worked on these cages where you can scale up the Temrixia production for over 300 wasps being produced for a per need release system. Basically, he would encapsulate the citrus plant with this big cage and throw in a lot of ACP and produce a lot of wasps to be released, or actually to be released by the state, right? What we are trying to do is, based on the data that I showed previously and this system that he has developed, to revise or somehow remake these schedules so they can be self-efficient and for self-releases of Temrixia. Nobody has done this before. We will also work with the plants that go inside, and we want to use the curry leaf plant as being something that it's an ACP host, but not the HLB host. And it's more attractive for the ACP compared to citrus, and it produces and flushes more regularly. So it gets more of ACP being produced in food. And then we'll throw in the Temrixia, and we'll try to scale up our production. So we'll investigate how far we can go scaling up the production, what kind of plant we can use, and finally, what kind of ratio we need within these cages. And also, we will modify the rooftop so that it's small enough to release Temrixia, but not the ACP from these cages. And finally, they will be self-destructed, or we will destroy them after they're being used and released. So the goal of this program and the idea is to have them established somewhere outside, possibly, or inside, but we still have to keep focused on the insecticide sprays. So everything is under development right now so that we can use them in commercial settings and release these wasps into commercial areas as much as possible and as efficient as possible. So this is a program in development. Like I said, we have to work around different obstacles, around different production areas. So please stay tuned. This will be happening in the next couple of years or maybe 3 years. Right now, we're tweaking around the ratios, the production system, and the plants. But the next year, we'll be coming into a field and trying to establish them in fields. And I see, again, Ventura as a possible location for this. As I know, previously working with Mark and being present in Ventura and giving a lot of talks, this is something that can fit into that program very efficiently, and hopefully we can test it in your area. So if you have a grow that you would like to participate in this grant, please let me know. You have my email, and I will provide it at the end of this talk. But we really need the test sites to really tweak around what we can do about Temrixia releases in commercial settings. Okay, and with this, I'm not going to take too much time on ants. Again, Mark covered this, and Maureen asked me not to. But there are two different types of gels. The one that I worked with in Mark's lab are the hydrogels, the seaweed-based hydrogels. We have tested Timetoxam, a lot of different products. Timetoxam works at a smaller rate. And we have a spinosad that we have tested that works at a higher rate, but this is still way below the label rate for these pesticides to be used. David Haviland, you can see it in the top right corner writing this ATV, has worked with polyacrylamide hydrogels that you can buy online and use them as a carrier, but he has tested only Timetoxam at a similar rate. It works, but not spinosad at all. So this year we'll be focusing on, I got some grant money to work with David on what kind of different levels of sugar we can use inside these gels, because sugar hasn't been a problem for us in Huddle Lab. We got that from our UCR Quantine, right, from the kitchen. We haven't paid for it a lot, but David has paid a lot for the sugar, especially if you're doing this per acre treatments, and this can be costly to your growers. So we'll be tweaking around the rates of sugar that can go inside these gels, as well as on different products and different rates per acre basis, because it will be all scaled up to a commercial applications and applicable to the growers. The major obstacle that we have, and Mark mentioned this, is with the registration. David has been instrumental in really trying to organize and trying to get it done with the DPR. And I have been helping a lot with this program as an industry-based specialist. So David and I have been in a lot of talks about how to make and how to approach DPR with this. And we're still working on our different parts of this application. Mark has been involved as well. So hopefully we can get some emergency registration soon for you guys to be able to actually be able to implement this in your orchards. So with that in mind, here's my email. You have my phone number as well. And I'm happy to take any questions if you have them for me now as well. Thank you.
Thank you so much, Ivan. One of the questions that I saw in the chat is, could you compare and contrast the funding that's being allocated for the Tamarixia research versus hoverflies versus hydrogels?
Okay, yes, let me just share my screen one more. So I'll leave it this way. Yes, so for Tamarixia, we just recently got a pre-proposal to work on, tweak around different, like I mentioned, different things that can go within the stages, within the cages, and try to develop them. And we are hoping to receive a grant for a field level application soon. That has been a priority by the industry, as far as I know. With the efficacy of the hoverflies and the cover crops, nothing has been on a radar. We had our, for example, we had our RFPs, but nobody has applied to work on that. I'm hoping to see more and work with Mark. We have some talks in the development on that for the next year, and actually do more of that in a commercial settings, and try to develop where these crops, as Mark has mentioned, can go. But really, if we can do something about that within the craft program, I would love to do that as well. This is an option. Our current biocontrol program is focused on whatever you can get from the UCI-PM guidelines and online, like lacewings and ladybugs, not on Tamarixia. So this is something that can be fitted into a craft program if someone is interested. But so basically, if you have growers in Ventura that would like to apply for a biocontrol, and you have Mark on board, and we all agree that this is something that can be compensated for, I don't see a problem of implementing this even right now. But growers will have to participate in the craft. So there is an option within the craft to actually tweak around, like I mentioned, and this is something that I want to bring into the industry and see what we can do about them for example, in the future, and tweak around the different placement of these cover crops. And hopefully we can get more money in the next year then as well on some of the grants, either through an industry or the state. But to the best of my knowledge, and maybe Mark has more experience with this and maybe knows more, I don't think anybody's like really allocating money for this, because it still needs to be developed and on another scale for growers to use, and UCI-PM guidelines to be revised. So I think that's the current issue, but maybe you have other opinions in the audience. Sorry. So as far as I know, Tamarixia, like I said, will be funded, and this is something that we're all excited about. But cover crops, not so much for now. So that's all I know for now. But maybe somebody else has more inputs on this. Thank you.
Great. Do we have any audience questions for Ivan? No? All right. Do we have any final questions? If our experts have already left, then I can mark them down and try to get answers back. But does anyone have any last, I wish I had asked this earlier, questions? Awesome. All right. Well, I want to thank United. They gave us this room for free, and coffee and waters, all for free, to support the work that you all are doing, and the water that you buy, I'm sure, as well as obviously the good work of the task force. A lot of task force members here. We're wrapping up because it's lunchtime. If you wish that there had been lunch, then consider sponsoring this event next year. Otherwise, I really want to thank all of our experts. Some people came from really far away to be here in person, and please swap business cards with them. We've got a bunch of fruit fly people here if you have fruit fly questions or CDFA questions. And yeah, just a really heartfelt thank you to everyone who makes this meeting possible. Thank you.